Buenos días, nos alegra y honra en sobremanera que nos acompañe en la mañana de este viernes en este encuentro estelar organizado por el Instituto Tecnológico de Santo Domingo y el equipo Apolo 27 con el objetivo de consolidar la presencia y expansión de las STEM en nuestro país. En esta jornada tendremos la oportunidad y el privilegio de escuchar 3 conferencias magistrales. La primera, encabezada por una comitiva representativa estudiantil de la Universidad de Alabama. Seguida a escucharemos la ponencia del director de STEM de la NASA y finalizaremos el encuentro con la participación del tutor del equipo NASA HERC de la Universidad de Alabama. Sabemos que cada charla servirá para motivar a que los jóvenes dominicanos encuentren un futuro inspirador y prometedor en las carreras de ciencias, tecnología, ingeniería y matemáticas. Permítanos destacar la presencia de las autoridades del INTEC, también autoridades gubernamentales y de diferentes instituciones académicas que nos acompañan. Tenemos el auditorio OCES repleto de personas, así que quizás en el día de hoy, por ese motivo, las salutaciones se extiendan un poquito, pero es lo que corresponde a nivel protocolar. Saludamos a las autoridades del INTEC, el vicerrector académico, el ingeniero Arturo del Villar. Igualmente se encuentra entre nosotros el decano del área de ingenierías, el ingeniero Cayetano Rodríguez, el tutor del equipo del NASA HERC del INTEC, el ingeniero Ezequiel Díaz. A todos los chicos igualmente del equipo Apolo 27, también externarles un afectuoso saludo. Igualmente a los demás miembros del Consejo Académico, demás decanos del INTEC, coordinadores de área, profesores y estudiantes, así como egresados que nos acompañan en esta mañana. También queremos destacar la presencia de las autoridades gubernamentales que se encuentran en este auditorio. Por el Ministerio de Defensa nos acompaña el viceministro de Asuntos Aéreos y Espaciales, Mayor General Muñoz Novoa, Fuerzas Armadas de la República Dominicana. El decano de la Facultad de Ciencias Aeronáuticas del Ministerio de Defensa, Coronel Rafael Ferrera. Por el Ministerio de Educación Superior, Ciencia y Tecnología, MESCyT, el encargado del Departamento de Gestión de la Innovación del Viceministerio de Ciencia y Tecnología, maestro Cordero Brito. También se encuentran en ese auditorio la diputada Patricia Núñez, representantes de la Superintendencia de Electricidad, el ingeniero aeroespacial del MIT, Ángel Gómez, el señor Ángel Gómez, la decana del área de ingenierías de la UNFU, señora Doris Peña, representantes del equipo NASA HERC de Iberia, Bávaro, Conexus, Liceo Científico de Tenares y del Colegio Loyola. Por supuesto, no podemos dejar de mencionar ni saludar a los que nos acompañan de la prestigiosa Universidad de Alabama en la ciudad de Huntsville, quienes se encuentran hoy entre nosotros. Al tutor especial del proyecto Moonbuji, el señor David Fikes y su señora esposa, Clara, para quien pido sí un fuerte aplauso. Asimismo, agradecemos la presencia de los miembros del equipo NASA HERC de la Universidad de Alabama en la ciudad de Huntsville, quienes pues en esta competición ganaron el primer lugar. Un fuerte también aplauso para ellos. De forma virtual desde la ciudad de Huntsville, conectado a través de Zoom, nos acompaña el director de la Oficina Regional del Sureste de Participación en STEM, el señor Kevin McHugh. Desde la virtualidad, como ya hemos mencionado, pues se estará conectando y también estará participando en este gran encuentro. Así que desde aquí, la República Dominicana, extendemos un gran saludo. Importante también mencionar a los patrocinadores que han hecho todo esto posible. De Cooperativas Reservas, el patrocinador oficial de esta visita, agradecemos pues el apoyo. También agradecemos al voluntariado Banreservas, Seguros Reservas y otros auspiciadores de la comunidad como CTAV. Por supuesto, también agradecemos y saludamos en general a todo el público que nos acompaña, como ya hemos mencionado, amigos, a quienes se conectan de forma virtual por el Instituto Tecnológico de Santo Domingo, por nuestro canal de YouTube. Esperamos nuevamente que esto sea una jornada de gran provecho para todos nosotros. Para iniciar entonces el desarrollo del programa, quiero llamar adelante al vicerrector académico de nuestra institución, el ingeniero Arturo del Villar, quien tiene unas palabras de bienvenida en nombre del Instituto Tecnológico de Santo Domingo. Con un aplauso les recibimos.
Muy buenos días a todos. En honor a nuestros invitados de Alabama, yo voy a hablar en inglés. Aquí todo el mundo habla inglés, me imagino, ¿verdad? Es así. In honor of our guest from Alabama, I'm going to talk in English. I'm not going to do it with a Southern accent, which I can perfectly do because I spent 20 years in Atlanta, Georgia. Atlanta, Georgia. So I can do it, but I'm not going to go into that. Ladies and gentlemen, good morning, and a warm welcome to all. It is a great honor to have you all here today as we celebrate the remarkable achievement in STEM education and innovation. I am particularly delighted to extend a special welcome to our distinguished guest, Mr. David McGaugh, Director of the Southeast Regional Office STEM in NASA, Professor David Howell, leading the STEM program at the University of Alabama, winners of the Robert Challenge 2024, Mr. Stalin Cordero, Director of the Innovation Ministry of Higher Education, Major General Leonel Muñoz, Vice Minister of the Defense Department, Coronel Rafael Herrera, Dean of the Faculty of Aeronautical Science in the Air Force, Equipo NASA, Liceo Científico Dr. Miguel Canela from Tenares in the high school category, Equipo NASA, Instituto Especializado de Estudios Superiores, Loyola, College category, Equipo NASA, Colegio Iberia de Santiago High School category, Equipo NASA, Colegio Bávaro High School category, Equipo NASA, Colegio Conexus de Santo Domingo High School category, members of the academic board, and all the other personalities in attendance here today. Welcome to my home, el Instituto Tecnológico de Santo Domingo. We are immensely proud to have our talented team from INTEC too, who secured an impressive second place in the same prestigious competition. Your dedication, ingenuity, and teamwork are a testament to the bright future of STEM education in our institution. STEM education, science, technology, engineering, and mathematics lies at the heart of our efforts to prepare the next generation of thinkers, innovators, and leaders. It is through STEM that we can address some of the most pressing challenges of our time, from climate change to healthcare, from sustainable energy to space exploration. By nurturing critical thinking, creativity, and problem-solving skill, we empower our students to shape a better world. Competitions like the Human Exploration Rover Challenge play a crucial role in this endeavor. They provide a platform for students to apply their theoretical knowledge in real-world scenarios, to innovate, and to push the boundaries of what is possible. These competitions foster a spirit of collaboration, resilience, and excellence. They also create opportunities for the students to engage with experts and peers from around the world, enriching their educational experience and broadening their horizons. Today, we celebrate not only the achievement of our students, but also the power of collaboration and the pursuit of excellence. The successes we honor today are the result of hard work, dedication, and a relentless pursuit of knowledge. They remind us of the incredible potential that resides within our young minds and the bright future they promise. To our guests from NASA and the University of Alabama, your presence here inspires us. Your achievements set a benchmark for our students, motivating them to strive for greater heights. To our INTEC team, your accomplishment in the Robert Challenge is a source of immense pride. You have demonstrated that with determination and teamwork, we can achieve remarkable things. Let us continue to support and encourage our students in their STEM endeavors. Let us continue to foster an environment where innovation thrives and where dreams take flight. Together, we can build a future that is not only technologically advanced, but also sustainable and inclusive. Thank you all for being here today. Let us celebrate the spirit of STEM and the bright future it holds. Congratulations to all, and enjoy the event. Thank you very much.
Agradecemos las palabras del ingeniero Arturo del Villar. Tenemos una actividad bilingüe. Nuestros invitados también están siendo, pues, les están traduciendo simultáneamente, así que esperamos que todos puedan entender todo lo que se va a hablar, ya sea en inglés o en español. Bien, queremos continuar dándole una participación especial al equipo Apolo 27. Cada año, el desafío de exploración humana en rover de la NASA, HERC, por sus siglas en inglés, presenta un reto de diseño de ingeniería para involucrar a estudiantes de todo el mundo en la próxima fase de la exploración espacial humana. Como parte del desafío estudiantil Artemis, HERC se inspira en las misiones Apolo y Artemis, enfatizando el diseño, la construcción y la prueba de tecnologías, así como la travesía en terrenos ambientales únicos. Desde el año 2019, el grupo Apolo 27 del INTEC viene haciendo historia año tras año tras convertirse en el primer grupo universitario de la República Dominicana en participar en esta competición. Este año no solo llenaron de orgullo a toda la familia intexiana, sino también que al conseguir el segundo lugar en el HERC y convirtiéndose además en el primer equipo de Latinoamérica en ganar uno de los primeros 3 lugares, han llenado de orgullo y satisfacción a todos los jóvenes dominicanos, influyendo en ellos esperanza de que sí se puede conseguir un mejor futuro. Además, este equipo Apolo 27 recibió por segundo año consecutivo el Spirit Award, premio otorgado al equipo con más dedicación, trabajo en equipo y cooperación. Su STEM Manager, Faisy Alcántara, estudiante de Ingeniería Biomédica, tiene palabras que compartir con todos nosotros, por lo que pido que para ella y para todo el equipo de Apolo 27 demos un fuerte aplauso.
Buenos días a todos. Es un honor y un privilegio estar aquí para dirigirme en nombre de Apolo 27 y del INTEC y darles la más cálida bienvenida. Nos sentimos profundamente honrados de contar con diferentes personalidades de distintas instituciones del país. Quiero extender un saludo especial a Stalin Cordero, encargado del Departamento de Gestión de la Innovación del MESCyT. Un aplauso para Stalin. También a nuestros representantes del Ministerio de Defensa, Leonel Muñoz Novoa, Coronel Rafael Ferrera, y también al Mayor General Técnico de Aviación, Carlos Febrillet. También quiero expresar nuestra gratitud por su presencia a nuestro vicerrector académico, Arturo del Villar, y a nuestro decano, Cayetano Rodríguez. Y a los representantes de la Superintendencia de Electricidad. Hoy es un día especial, pues tenemos el privilegio de contar con la presencia de estudiantes y profesionales de Huntsville, Alabama. Un afectuoso saludo a nuestros distinguidos invitados. Tenemos de manera virtual al director de la Oficina Regional del Suroeste de STEM Engagement de la NASA, Kevin McHugh. Y aquí con nosotros al tutor del equipo de Alabama, David Fikes, y a su esposa, Clara Fikes, así como a todos los miembros del equipo de la Universidad de Alabama en Huntsville, Carissa Coggins, Elijah Rose, Rosa Rice y William Ashley. También agradecemos profundamente a las autoridades y estudiantes de otras instituciones invitadas, así como comité de padres, prensa y público general, que también nos honran con su presencia. Un aplauso para todos. Gracias a todos por estar aquí y compartir este gran evento con nosotros. Para Apolo 27 y el INTEC, este es un momento trascendental, ya que tener la oportunidad de recibir a Alabama, a los estudiantes de la Universidad de Alabama y a representantes de la NASA aquí con nosotros, es un sueño hecho realidad. Esta visita es el resultado del esfuerzo colectivo y la materialización de una visión compartida, que es promover las STEM en la República Dominicana y contribuir al avance tecnológico de nuestro país. Para nosotros, las STEM son mucho más que un conjunto de disciplinas. Son el motor que impulsa el progreso y la innovación. para nosotros representan una oportunidad para transformar nuestras aspiraciones en realidades tangibles, para inspirar a la juventud dominicana a soñar en grande y a perseguir sus sueños con pasión y determinación. Cada proyecto, cada desafío y cada logro que hemos alcanzado ha sido un paso hacia adelante para nuestra misión, que es elevar el perfil de las STEM en la República Dominicana. Hoy en nuestra agenda vamos a estar escuchando la valiosa experiencia de los estudiantes y profesionales que han trabajado arduamente para llegar hasta aquí. Ellos compartirán sus conocimientos sobre esta competencia y la importancia de la exploración espacial, enriqueciendo nuestra comprensión y motivándonos a seguir explorando nuevos horizontes. Tener a Kevin de manera virtual es un gran honor, ya que la NASA no solo lidera el camino en la exploración espacial, sino que también juega un papel crucial en la promoción de las STEM a nivel mundial. La NASA ha demostrado una y otra vez su compromiso con la educación, compartiendo generosamente sus conocimientos y experiencias no solo con su país, sino con todo el mundo. Su grandeza radica en su capacidad para inspirar y empoderar a jóvenes de todos los rincones del mundo, mostrando que con dedicación y pasión es posible alcanzar las estrellas y más allá. También quiero destacar que nos sentimos muy orgullosos de la Universidad de Alabama en Huntsville, ya que ver un equipo tan excelente, admirable y al mismo tiempo humilde nos llena de mucho orgullo. Ustedes han sido una fuente constante de inspiración para nosotros, demostrando con su trabajo y dedicación que la grandeza puede ir de la mano con la humildad. Su éxito es un reflejo de la calidad y el compromiso que nosotros aspiramos a hacer en nuestro propio camino. En nombre del equipo, le agradecemos de corazón acompañarnos en este día tan especial. Esperamos que esta visita sea el inicio de una colaboración fructífera y duradera, que nos permita seguir avanzando en nuestra promoción de promover las STEM y contribuir al desarrollo de nuestro país. Juntos estamos construyendo un futuro más brillante para la República Dominicana y para el mundo. Como dijo John Gordon, los buenos líderes no tienen éxito por ser grandes personas, tienen éxito porque revelan la grandeza de los demás. Gracias.
Gracias, Faisy Alcántara, y enhorabuena para todos los integrantes de Apolo 27 por dejar la bandera dominicana bien en alto en tierras extranjeras. Estamos muy orgullosos de ustedes y estamos convencidos que para cada uno de los integrantes de Apolo 27, la luna sí que es el límite. Vamos a continuar ahora con las palabras del representante del MESCyT, el señor Cordero Brito, quien es el encargado del Departamento de Gestión de la Innovación del Viceministerio de Ciencia y Tecnología. Un fuerte aplauso para el señor Cordero.
Muy buenos días a todos y a todas. Ingeniero Arturo del Villar, vicerrector académico del Instituto Tecnológico de Santo Domingo, INTEC, y con usted a los demás vicerrectores, vicerrectoras, decanos y decanas de esta prestigiosa casa de estudio. Mayor General Piloto Leonel Muñoz Novoa, viceministro de Defensa para Asuntos Aéreos y Espaciales. Distinguida Patricia Núñez, diputada de Santo Domingo Norte. Distinguido Kevin Michael Magá, director de la Oficina Regional del Suroeste de la Participación STEM de la NASA. David Howell Fikes, profesor y tutor del equipo NASA-HER de la Universidad de Alabama. Representantes de NASA-HER, invitados especiales de la Universidad de Alabama, funcionarios y funcionarias aquí presentes, amigos de la prensa, señoras y señores. En nombre del ministro de Educación Superior, Ciencia y Tecnología, doctor Franklin García Fermín, y del doctor Genaro Rodríguez Martínez, viceministro de Ciencia y Tecnología, es un placer estar aquí en un hecho histórico, porque marca un hito en todo lo que tiene que ver con la ciencia, la tecnología, las matemáticas, la ingeniería en nuestro país. Me place darles esta bienvenida y quiero destacar a los equipos aquí presentes del NASA-HER de diferentes institutos educativos, entre ellos el Liceo Científico Miguel Canela de Tenares, el Colegio Iberia de Santiago, el Instituto Colegio Bávaro, el Colegio Conexus, todos estos de la categoría de secundaria, y el Instituto Tecnológico de Santo Domingo, INTEC, y Loyola en las categorías universitarias. Su compromiso y entusiasmo en el ámbito de las STEM es un testimonio de lo que pueden hacer los jóvenes en nuestro país. Para ellos, un fuerte aplauso. Es bueno enfatizar que un factor determinante para el desarrollo endógeno, crecimiento y desarrollo de nuestro país, es tener las capacidades para aplicar y transferir conocimiento. En los países más industrializados se ha construido un desarrollo económico en base a la formación del capital humano. Es bueno que lean el libro de David Borjas para que vean la dirección positiva entre los años de escolaridad y todo lo que tiene que ver con el aumento de los salarios. Para citar algunos, Estados Unidos, Singapur, China, Taiwán, Corea han aumentado la capacidad de la fuerza laboral y han establecido niveles educativos de calidad, sobre todo en ciencia y tecnología. Es importante destacar que en los últimos 10 años el crecimiento de los empleos STEM ha crecido 3 veces más que el crecimiento de los empleos no STEM. Es decir, que de aquí al 2030, el 80% de los empleos que actualmente son demandados serán reemplazados por empleos de carreras STEM y algunos que aún ni siquiera imaginamos. Es por esa razón que el presidente de la República, Luis Abinader, ha instruido al Ministerio de Educación Superior a seguir tomando iniciativas que vayan en esa dirección. Por lo que se han implementado programas educativos desde grado hasta posgrado para seguir trabajando estos temas. Para poner algunos, se están priorizando unos acuerdos entre el Ministerio de Educación Superior y todas las IES del país para crear los centros de excelencia en innovación y transformación digital. 7 centros de excelencia en I+D+I. Y también todo lo que tiene que ver con el apoyo con becas nacionales y becas internacionales para todos los jóvenes talentosos. De allí, los jóvenes de Apolo 27, que no son una excepción. Un aplauso para ellos. Todo esto para fomentar tener un talento humano necesario para llevarlos al mundo laboral, pero con lo que el sector productivo necesita a corto, mediano y largo plazo. De allí también surge la Feria Universitaria Dominicana Innova. No sé quiénes han participado en esta feria, pero con esa feria lo que buscamos es visibilizar todos los temas de innovación, vinculación universidad-empresa, ciencia, tecnología y emprendimiento. Estuvimos en el atrio de Agora Mall enfatizando las carreras STEM y que las mujeres tengan la participación que se merecen en estas áreas. 15,000 participantes estuvieron allí y seguimos el año que viene. Es en ese orden que asevero que este evento es más que una serie de ciclo de conferencias. Es una celebración de la innovación, la colaboración y el espíritu de superación. Nos brinda la oportunidad de aprender, de inspirarnos, de crear nuevas alianzas y seguir por el camino del cambio. Por ende, quiero culminar con una frase de Derek Book, ex rector de la Universidad de Harvard, para todos los jóvenes que están aquí. Si piensan que el camino de la formación es largo y tortuoso, intenten con la ignorancia. Muchas gracias.
Agradecemos las palabras del representante del MESCyT y nos alegra saber que desde el Estado nuestras autoridades pues están comprometidas a mejorar y apoyar el desarrollo de las STEM en nuestro país. Entonces, estamos listos para el despegue que nos llevará a conocer sobre la construcción de naves, satélites, de las ciencias aeroespaciales, así como las estructuras y divisiones de trabajo dentro de la NASA. Sí. Yes. Ok, perfecto. Pues es el momento de iniciar con las conferencias. Importante mencionar que al final de cada una de ellas habrá una ronda de preguntas y respuestas donde quienes tengan dudas pues podrán aprovechar a los oradores que tenemos invitados en el día de hoy. Iniciamos nuestra primera conferencia bajo el título Unveiling Moon Buggies, por los miembros del equipo NASA HERC de la Universidad de Alabama en la ciudad de Huntsville, quienes vienen además acompañados junto a su maestro, el señor David Fikes. Voy a mencionar de forma general quiénes son los integrantes del equipo de la Universidad de Alabama que nos acompañan y que estarán compartiendo con nosotros. Carissa Hope Coguin, la team leader, Rosa Elizabeth Rice, quien es el coordinador líder de STEM, Eliaj Miles Rose, líder de ensamblaje, y William Gardner Ashley, líder de equipo de diseño. Con un aplauso recibimos al profesor David. Yes.
Good morning. What an honor it is to be in your country. My team and I just really appreciate your invitation to come and share our passion about HERC and about STEM outreach and about cooperation between countries and universities. And it's just been a fun time. I was telling Ezekiel this is going to be the high point of my summer. And Fossey was saying y'all are warm and friendly and happy people, and we have found that to be so very true, and we really appreciate you. And thank you for your hospitality. I also wanted to say something real quick here, that there's somebody that's going to be really surprised about this event, and we're able to be a part of it. And that is the STEM outreach that is so important to NASA. They need to hear this story about us and you cooperating and talking to each other. And they are going to be really thrilled to see that, you know, the two countries and two HERC teams came together in the interest of STEM and to cooperate and to help the young people have a vision for the future. And that's a big deal to NASA. And I don't know how many times this has happened across the world, but if this is the first time, it's a start, and it needs to continue the cooperation between HERC teams, and I really appreciate it. And I think that our presentation the team's going to give will inspire you and help you see some things, and because you've helped us see a bigger vision for the future of young people in STEM outreach, and I'm hoping this presentation will in turn help you. And so I'm going to turn it over to the team and let them do all the talking, and I appreciate you having us here, and we thank you very much.
Good morning, everyone. I'd like to start out by, again, reiterating what Mr. Fikes was saying. We are so thankful for the hospitality that you all have shown us this far. This trip has been above and beyond anything we possibly could have imagined. Without further ado, we'll go ahead and get started with our presentation. We're going to be presenting today about our moon buggy experience. We want to unveil the moon buggy experience that we have at UAH and share it with you all. So going through the slides, we will first talk about who we are, what HERC is, the different senior design capstone projects UAH offers, how UAH supports us in the project, and all of our competition, experience, and how we got here and how much we love HERC. So to introduce ourselves, we are from the University of Alabama in Huntsville. Our total enrollment for 2023 was 8,743 students. In the College of Engineering, we had about 3,000 students. This college is our university's largest academic college, and there are 9 of these. We have 94 degree programs, which are bachelor's, master's, and doctorate in philosophy. We are ranked #1 in return on investment in Alabama for a university, and that is a comparison of the money that you spend to go to the college in comparison to the money that you make after college. It's a measure of how much you as a student are getting out of university. So some more about UAH academics. UAH is considered a Tier 1 research school in the U.S. Our school spent $163.4 million in research funding last year, or in fiscal year 2022. This funding comes from different national grants for research and advancement of technology, and also from federal funding for professors to conduct their own research. Our areas of research span a wide variety of STEM subject areas. These are propulsion, optics, materials, electrodynamics, advanced robotics, controls, composites, electrochemistry, civil infrastructure, and even more. If there is an area of research, there's probably someone at UAH who has thought about investigating it. Last year, 11 patents were awarded to UAH inventors, which I thought was really cool. That means you have professors who are innovating and making brand new things for the advancement of technology. We as a team, we are the UAH Moon Buggy team. At UAH, we like to call the Human Exploration Rover Challenge Moon Buggy. The Great Moon Buggy Race was the original name of the HERC Challenge, and so it's a name that's carried through. We love it. Sounds very fun. This year, our team took home first place in the college division, which we were very proud of. We worked hard all year, and it was really very a point of pride for us to see all of our hard work come through to fruition. Not only did we win the first place overall award, we also won the Project Review Award, which I personally was very proud of. Many late nights were spent writing reports. I know that's true for your team as well. Those reports, it's a great introduction to how technical writing goes. So our rover was called Theseus, and this is an acronym that stands for the Transportable Human Exploration System Equipped for Unconventional Surfaces. At UAH, we like to give our rover a fun name every year, and it was actually Mr. William Ashley who came up with it. It was very fun and creative. He brought that in on the second week of classes, and we all loved it, and we ran with it. So this is a picture of our rover this year. This was just after our final assembly. As you can see, those wheels still look very nice and new and shiny. They are not like that anymore. The competition made sure of that. And that's a picture of the back of our rover. We like to include a little mark on all of our rovers that show all of the people who contributed to the project. So that plate has every single team member's name on it, as well as special thanks to people who helped us out along the way. To introduce myself, my name is Carissa Coggin. I am the University of Alabama in Huntsville's team lead. This was a position that my peers chose me for, and I was very proud to help lead this team through the year. I graduated this past May. I am now working as a mechanical engineer. And my hobbies outside of school and academics are tennis, running, wakeboarding. I love pretty much anything outside. My contributions to the team really involved a lot of our deliverables. So I focused a lot on presentations, the technical writing side of it, ensuring everyone adhered to the schedule and our project was moving through as it should. I also worked on team management, which was conflict resolution. Thank you, Ingrid. Which was conflict resolution between different teams who were debating on which designs to choose and any decisions that needed to be made. I also worked in the wheel design and fabrication, and I was our team liaison to NASA.
So hello, everyone. Again, my name is Will Ashley. I was, I guess you could say, the team lead of the fabrication and design of the rover. So I was not purely in manufacturing, but I was a bit of a technical coordinator for a lot of those different efforts, and I really was able to touch just a little bit of all aspects of the project, which I really enjoyed. Helped out with some of the reports and technical writing, and I was the team lead of drivetrain, so I was involved in kind of the designing of the actual propelling of the rover. I'm also a mechanical engineer. I graduated just a few months ago, so that's great. Good luck to any of you guys who are also in your final push. You're almost there. And outside of school, I really enjoy also getting outdoors. I really enjoy mountain biking, hiking, kayaking, and the mechanical engineer runs deep in me because I love working on my car. So anyway, thank you guys so much.
Good morning. I'm Eli Rose. I also graduated this May. I work as an aerospace engineer after graduating. I like to mountain bike, go camping, and play video games on my spare time. For me, I was our task tool design lead, so I was in charge of making sure that our task tool was properly fabricated and designed and met all of the criteria that it needed to. And I was also our male rider, so that's where I dedicated a lot of my time to exercising in a gym and also a lot of time just practicing on the rover, practicing obstacles, and making sure that I had the endurance to complete everything on competition day.
Hello and good morning. My name is Rosa Rice, and I will be graduating this fall with a degree in mechanical engineering. Some of my hobbies are cycling and gymnastics, and my contributions to the team were as the STEM coordinator and the female writer. So I coordinated all of our STEM outreach events and designed our instructionables. I ran our social media accounts. I did our graphic design. I worked on rover assembly, and I spent around 10 to 15 hours a week practicing for riding. So I'm going to talk to you guys a little bit about what HERC is. So the Human Exploration Challenge is a yearly competition held by NASA in Huntsville, Alabama at the Space and Rocket Center. Teams from across the world work together to build a human-powered rover and a tool to do tasks along a simulated lunar course at the Space and Rocket Center. In addition to building this rover and task tool, teams are required to create reports and presentations which they deliver to NASA, as well as to hold science, technology, engineering, and math activities with students from kindergarten through grade 12. So from NASA, the primary objective of HERC is for teams of students to design, develop, build, and test human-powered rovers capable of traversing challenging terrain and a task tool for completion of various mission tasks. This is a short video from NASA showing some of the rovers from the competition day this year. So you'll see there are different tasks that they have to complete. So as you can see in this video, there are just so many different ideas that teams come up with for how to build their rovers, and the teamwork that happens during this competition is just like nothing else. So some of the competition requirements, students in this competition have to do more than just build a rover. They have to submit a proposal to NASA to show that they have the facilities to complete this task. They have to compose and present a design review as well as an operational readiness review to show that they have a plan, that they've stuck with this plan, and that they've made the required accommodations to that plan. Additionally, they have to provide educational STEM outreach opportunities to a minimum of 250 students. And what these educational opportunities have to be are direct, hands-on engagement with students. I think this is...
So I'm going to tell you a little bit more about Moonbuggy at UAH and our program. There we go, I figured out the clicker. So at UAH, students can participate in the HERC Challenge through an accredited course called Moonbuggy. So this is a senior capstone course at UAH, which means that this is a year-long class that incorporates all aspects of our engineering education. This is supposed to span every single class we've ever taken. So we go through technical writing, presentations, design, analysis, fabrication, and teamwork and cooperation. These are the goals that our class aims to accomplish, and we believe that the HERC Challenge encapsulates that very well. For us, Moonbuggy is a lot more than just a class or a club. To many of us, Moonbuggy is our favorite part of college and our favorite part of being an engineer so far. We've made lifelong friendships through the people we've met on the team. At the beginning of the year, many of us did not know each other and had never met, and a month later, we were all super good friends, we were all really close, and now we're hanging out just about, every day, every week, and we have a lot of fun. Some of those pictures are from the competition and from the academic year. We did a fun presentation. We have a internal preliminary design review, and it happened to fall on Halloween. We dressed up in costumes for that. And you can see our team members pointing at the rocket because it's very impressive. So we just have a lot of fun with the competition and everything involved with it. So at UAH, Moon Buggy started in 1994, and we competed in the very first competition hosted by NASA. This originally was called the Great Moon Buggy Race, and UAH would take the first win. During UAH's time of competing in HERC, many things have changed. Initially, the only goal was to be the fastest rover around the course. So you saw a lot of super light, super fast rovers that would fly around the course in 3 minutes. And they also had a different course. It was on pavement, not on grass. I'm sure the riders were thankful for that. And in 2016, wheel requirements were changed so that you had to manufacture your own wheels. And I know, personally for us, the wheels were one of the most challenging part. You really have to have good wheels to make your rover go anywhere at all. And so this was a very big challenge. And in 2018, tasks were added to the course. This was a very big shift in the competition. It meant that a lot more of the points were going to come from a secondary design aspect. And so it really helps students approach this less as a race and more of an actual lunar mission where you have to have a tool to accomplish tasks. Today, HERC is called, well, the Great Moon Buggy Race was changed to the Human Exploration Rover Challenge. This challenge is one of the NASA Artemis student challenges, and it seeks to encourage and inspire the upcoming generation of explorers. The Artemis program aims to build upon what we learned from the Apollo missions to return to the moon and beyond and inspire the next generation. And it's taking inspiration from the Artemis program. HERC simulates the tasks and challenges future astronauts may encounter on the lunar or Martian missions. Every year there's a HERC handbook released, and there's a little story in it that's telling you what kind of mission you're hoping to accomplish. So this year we were hoping to recover some samples. We were hoping to clean off a solar panel and charge up a battery. And so we were really pretending to be astronauts in this competition. It was a lot of fun. As a class, Moon Buggy it gives us the opportunity to get course credit by participating in the HERC Challenge. Completing this project as a class rather than a club is beneficial for several reasons. One of the main reasons is that we are able to dedicate a lot more time to this program because it's kind of like doing homework for us. So students have to make time to do their homework, and we have to make time to do Moon Buggy. And there's other things that go into this class too, which I'll go into a little bit later. Students also show more investment in this program because we're spending so much more time together. We really get ingrained into the project as a whole. We also receive financial aid and technical support from our university for this project, and we'll go into that as well with our facilities and where our funding comes from. And we also get use of the university machine shop. We have a classroom, we have a storage space, and we have access to all the other facilities to help us out in this project. So a senior design capstone involves the application of engineering design principles acquired in prior engineering classes. All mechanical and aerospace students at the University of Alabama in Huntsville are required to take a senior design capstone course to complete our graduation requirements. These courses are project-based and give students hands-on experience which can help them in their future careers. HERC really emulates a project you would encounter in employment. So you start with a proposal, you go all the way through the design process, you have to get things approved, you have to meet requirements, and then you have to see this product through all the way to realization. The senior design capstone courses receive support from the university financially and through the use of all of our campus resources. The principles for a capstone are design methodology, decision-making, product liability, ethics, human factors, creativity, patents, and technical writing. The HERC program really meets most of these, which is a really great thing. And Will is going to tell you more about the other options for senior design at UAH.
So at UAH, the only capstone is not just HERC. We have many others. So at our school, we have, there are 5 different options, but 2 of them are pretty similar. So we have, obviously, HERC, the one that we did. There's also our rocket design class, which is a competition for NASA. We also have electric vehicle, which is, I'll talk about it more, but it's heavily mechanical. And then mission design, which works with different companies around Huntsville and helps them develop missions primarily for like the aerospace field. So the first one is rocket design. So this is a NASA competition similar to HERC. It's called the Student Launch Initiative. And in this, students need to design a rocket that has, in this year's case, a payload. And then that needs to be launched up, and then it needs to perform its specific tasks and then return safely. We also have electric vehicle design, which is a little bit different than many of the others. Most of our other competitions or senior designs are a one-year thing. So for HERC, we begin designing and we finish it all in 1 year. Electric vehicle is a much longer process. It's been happening for several years now and will continue to, and it's different teams every year, but they keep working on the same vehicle in hopes that one day we'll be able to race it in a competition. We also have the mission design development. So primarily, one of our large people that we interact with this is NASA. And so this year we had some things like designing missions for habitats or launching systems into space. And students have an opportunity to work with these companies and contractors in order to put something into space and really get an idea of what sort of the more mission and it's a little less hands-on, but a little more understanding the whole system and how everything operates within it. So at UAH, we have a way of choosing our senior designs. So everybody is given an option between, well, all of the aerospace and mechanical engineers are given an option for the 5 different senior design capstones. And we rank each of these based off of which one we'd like to do most. And once we've submitted that to the school looks at it, and they decide based off of our GPA, how we've been performing, along with how, like, our experience, like in the case with HERC, with machine experience so that we can machine the rover, they decide where we end up for each of these senior capstones.
So I want to touch on just a little bit about our accreditation process as a university. So UAH is an ABET accredited university that is the accreditation board for engineering and technology, which is an ISO certified quality assurance organization that allows us to meet a benchmark standard within the US and internationally for different science and engineering technology organizations. And so for our university to be accredited, we have to meet certain outcomes. And some of those are that it verifies your educational experience and it enhances your employment opportunities to be a part of a university that is ABET accredited, because that's something that many companies may look for on your degree. So some of those ABET requirements are you have to have an ability upon graduating to apply engineering design to produce solutions meeting specified needs with certain engineering competencies. And one of the ways that our program meets that as Moonbuggy to be ABET accredited is we do that through our design reports, which is a very intense technical document composition, our operational readiness review report, which is very similar, and of course our rover and task tool for the NASA competition are a deliverable engineered product that we spend a lot of time on, just like in the real engineering life cycle. Next, you have to have an ability to communicate effectively with a range of audiences. We as engineers know sometimes we're not always the most extroverted, easy to talk kind of people. So it's very important that as engineers we really cultivate these soft skills, as they're called, that really make us well-rounded people and good at explaining our ideas. And Moonbuggy is absolutely excellent for that, as I can say from my personal experience, even being here speaking to you today with this opportunity. So we have lots of individual public speaking events through our STEM outreach. We also have, of course, our design review and ORR, operational readiness review presentations, which are a very formalized presentation that we do directly to NASA. And we have our internal project reviews as well, which would be our preliminary design review and our critical design review to ensure that the team has good synthesis and internal communication. We have to have the ability to recognize ethical and professional responsibilities in engineering situations and make informed good judgments for the public based on that. So it's important in our program as well that we're emphasizing not just the how we produce good products as engineers, but we also need to be sure that we're doing things that are ethical and in the interest of the public as we are going about that. So we have what NASA very much emphasizes is a hazard risk assessment section of our reports and presentations. So we spend a lot of time analyzing the different risks that could be associated with physical harm, and we put a lot of effort into mitigating those and explaining how we are going to do that, which is something very good because that is extremely important in industry in any engineering discipline. We also study ethics case studies, so we look at previous engineering failures and disasters, and we analyze where along the chain did those have problems. Where could someone have made a better ethical decision which could have prevented a disaster or potentially saved lives? And of course, from our hazard analysis, we're doing implementation of our safety operating procedures, our SOPs, which regulate how we're able to conduct ourselves when we're practicing, riding, or even just working in the machine shop. We have to have an ability to function effectively together with team members and provide leadership and collaboration, plan our tasks, and meet our objectives. So ultimately, you have to be able to get the job done at the end of the day. And we make sure that we do this through a few different coordinations. So we have our weekly individual reports, which is where you'll compile all the things that you're doing and have done throughout the week as a part of accountability, and we present those to Mr. Fikes for him to review to make sure we're staying on task. We next have bi-weekly team updates, which we would use our class time for, where we all make sure that we're on the same page. Each subs team is interfacing well with the other ones to make sure that we're creating a cohesive product that will actually fit together when we get it done. And we also will have an individual survey at the end of the semester where you will rank your team members on how they performed. So it's very important to make sure, nothing will get by anyone. We're all watching each other. We're making sure that everyone's pulling their weight. And it's not generally something we have to worry about because we've been very blessed to have a very functional team, and we really work very well together. Another part is acquiring and applying new knowledge as needed and using appropriate learning strategies. Because engineers, it's very important that we don't just go to school for 4 years and then we know everything and we go build a product. We're constantly learning until the day we retire and maybe even after. So it's very important to be open to learning and to having a strategy for gaining those skills once you're already in the workforce. And so we meet that because we ultimately have to produce a final product, the rover and the task tool. We have to have training in our machine shop. That's a continuous learning process, and it's different. We'll touch on it more later, but there are varying degrees of how much you're actually learning there. For some of us, it was an incredibly deep experience that we got through that. And then overall, the systems engineering and design and documentation process is an important part of how we are actually learning new things and then applying those.
So as part of our ABET accreditation, we have to address certain topics in our engineering classes. One of these is ethics. As engineers, you're going to be put in charge of some project or a problem to solve, which means you will have a responsibility to keep people safe. So it does not matter if the project is something large, such as building a bridge. You have to make sure that the bridge is structurally stable and during the construction process, all safety requirements are met. Or it could be something as small as changing a process in a production facility that maybe the process needed some safety improvements. You want to address that to keep the workers safe. So in ethics, in our courses, we have to address different safety hazards that are present in our shop. So through this, we want to keep each other safe and do a balance of safe operations, but also being able to get the project done. So we would like to really prioritize safety, and we keep that at a high standard. In the Moonbuggy class, we do examinations of ethics cases related to different engineering disasters and failures, and identify errors in the decision-making and safety management that occurred. One example of one of these cases covered was the Florida International University bridge collapse, which is an example of a very large failure in engineering oversight. And in this case, we identified what went wrong, what decisions could have been changed to keep people safe and prevent the loss of life and the project. So Moonbuggy is a class for us. That means that we receive a grade in it, such as, A, B, C, D, fail. So through this, we have different assignments that we're graded on. One of these is our weekly activity reports. During the semester, we keep a comprehensive journal of everything that we have done to really serve as proof that we are participating in the team. We also have homework assignments that are somewhat unrelated to the Moonbuggy project, but are necessary to meet our ABET accreditation. These are problems such as design and analysis of different problems, such as designing a bridge to cross a gap. So we use our analysis skills in this respect, and we have to prove to Mr. Fikes that we actually have learned in our engineering education. And some assignments are more on the soft skills side. These cover Alabama space history and the history of the Moonbuggy program. These are for us to develop our writing skills and develop documents. Participation is also a very large part of our grade, which is needed for a project like Moonbuggy. So all students are required to attend events called Discovery Days at UAH. These are university recruiting events where we go and we showcase our senior design projects. There are members from all the senior designs present showcasing what they're doing and how they're doing it. And this is really an enjoyable activity for us. We also do peer reviews at the end of every semester. This is where we rank the different members that we worked with on the teams. We like to split up into sub-teams to address all parts of the rover. And so on any team project, you may have someone who does more or maybe does less, and we want to let Mr. Fikes know who participated and who did what. In general, though, participation is not a problem. As Will mentioned, we always have a really great team who likes to come together and to contribute to the project. Everyone wants to contribute to the project so that they can say they had a hand in it whenever they see it rolling down the course. As a university senior design capstone project, we receive partial funding through our university. Every semester, students pay a College of Engineering fee. Usually this fee is a lot higher during your senior year because you're participating in a senior design. And based on what we receive from our university, divided by the number of students we had in the class, we estimate that about $375 that we paid toward this fee came back to our senior design program. Every year for additional funding, the UH Moonbuggy team submits a proposal to an organization called the Alabama Space Grant Consortium. This is a foundation whose mission is to engage young people in STEM and expand STEM opportunities across the state. So we submit this proposal in the hopes that they choose to give us some funding for our project. And this year we were lucky enough to receive funding from them, which is a really great experience in document preparation and writing a proposal in search of funding. Full participation is a requirement of the Moonbuggy Senior Design Program. At the beginning of the semester, we all sat down and decided what sub-teams we wanted to be a part of. For example, these are things like the wheels team, the suspension team, the frame team, the drivetrain team. They are things like that where we break the rover down into smaller sections so that no one group of people has to tackle a too large project. Students are expected to contribute to the sub-teams that they choose to sign up for, which teaches responsibility and work ethic. By signing up for that sub-team, you're saying that, yes, I will contribute to this to my fullest extent. The peer assessment at the end really allows for accountability in the team so that we know that everyone is contributing at a reasonable level. And I want to note that we do say a reasonable level. There's always students that go far above and beyond what we request of them. For example, we spend very late nights in the machine shop. We'll stay there until 12 a.m., very late, and we'll work on documents until the sun comes up, which is a lot of fun, but also a lot of work. And we would never expect anyone to stay up all night long to work on the Moonbuggy project. So we just ask for reasonable participation. Some of the homework that we have in Moonbuggy is related to the project itself, which is a majority of the work that we do as homework. Other homework assignments include a design project, where we have to use the analytical skills that we acquired in previous classes to design, for example, a bridge. This really brings in together statics, mechanics of materials, and lets us practice our analysis of a full system. We also have different ethics assignments where we had to review those failures and talk about why they failed and how we could, as engineers, do better. We also have to do Moonbuggy and Alabama Space History assignments, which are for us to develop our writing skills, but it also really brings awareness for us about what goes on in our city. Most of us are from either the Huntsville area or we have moved to the Huntsville area for school, and so we think it's very important that we know the history of the area and how our city has contributed to aerospace. We also have internal project reviews for our Moonbuggy project. These are the preliminary design review and the critical design review. These are a part of the NASA Systems Engineering Handbook, which we drew a lot of inspiration from in the organization of our project. During the preliminary design review, or the PDR, which we did in the fall semester, we went through all of the different design choices that the sub-teams had developed for rover subsystems, and we made choices as to which ones would be implemented in our final rover design. This really brought together the whole team and made us realize what track we were going down. For the critical design review, this was conducted in the spring semester, and this was a verification that the rover was ready to go and all the subsystems could meet the requirements asked of them.
So on our HERC team this year, we had a total of 32 students, and within the team we have some diversities and sort of statistics showing of how things change throughout the semester. So at the beginning of our semester, well, and at the end, we had around 1/3 of our population as aerospace students and the other third as mechanical engineers. And this makes a lot of sense because most of what we're doing is on the ground. But the way that UAH is set up is that our mechanical and aerospace share senior capstones with each other. And so it's the same thing with competitions such as SLI, where they also will have some mechanical engineers, even though they're launching a rocket. We also had quite a few females on the team, with around 28% of our team being made up of females. This is higher than many of the other groups within the College of Engineering at UAH. Going into the competition year, we had 3 people who were certified to work in the machine shop and 1 experienced welder. And throughout the year, between all of us working on the projects, at the end we had a total of 7 people who were certified to work in our machine shop, still 1 welder, but also all of our students became certified to be able to work with basic machinery in the tool shop, such as drills, simple lathes, and things like that. But throughout the whole year, everybody on the team had the opportunity to get their hands dirty, touch metal, and actually manufacture the rover to some degree. We, after graduating, well, not necessarily graduating, after finishing the competition, we have around 1/3 of the class who are planning to pursue their master's degrees. And out of those, 2 of them are planning to do this full-time, while the rest are planning to work a job and do school at the same time. Along with this, 90% of our students, after finishing Moonbuggy, either have a job lined up or an internship that they'll be lining up to work with after graduation.
So many students from our Moonbuggy course can attest that Moonbuggy as a class is helpful even outside of a strictly academic environment. So this is a quote from one of our team members. She said, "As a systems engineer, Moonbuggy has taught me the importance of detailed documentation, well-written reports, and above all, why having people from a variety of backgrounds and subject matter experts assisting throughout the process is so important. As a member of the design and engineering team, Moonbuggy really instilled in me that the importance of collaboration and teamwork and how that sets a project up for success. As an engineer, Moonbuggy taught me the importance of utilizing resources available to me and asking for help when I'm at a standstill or overwhelmed with tasks." I think this quote really highlights the fact that Moonbuggy is a team effort, but that each individual team member will benefit greatly from this experience. So Moonbuggy on campus is a very visible organization. We do all of our practice rides throughout campus, so any visitors to campus, any tour groups, any high school students who are prospective students, they see us out practicing. And this boosts enrollment in our engineering program. So, are you going to talk about this?
Yeah, I'll talk about it.
Yes. Okay.
So, Moonbuggy is actually the reason why I decided to attend UAH. Every prospective student attends a Discovery Day, which is just a recruiting event for interested students to visit the university and see all of the different programs. Whenever I attended my Discovery Day in the fall of 2019, I saw the Moonbuggy team there, and I thought, wow, that's really cool. I want to do that. No other university I had visited had anything like that. I never saw them have something really cool built by students sitting there in front of us, and so I went to UAH.
So like Carissa mentioned, every prospective UAH student attends what's called a Discovery Day. At these Discovery Days, different groups from within the engineering departments, they come and they do a presentation about what work they do within their departments. So we had SLI, the rocketry team. We brought one of our moon buggies out along with a task tool to show these high school students, hey, you can do cool things in engineering. It's not just all math and coursework. So during these events, students are able to actually interact with us, the students, to get the inside information about what it's actually like at UAH. And wanted to mention, we interacted with about 100 prospective students during this event. Additionally, Moonbuggy makes for great publicity for UAH, so events like this, but also other events such as Alabama Space Day. We traveled to the capital of Alabama, Montgomery, to present at a booth with our, this is Theseus before it was painted blue. So different groups from the space industry within Alabama came together to really just highlight the importance of Alabama within the space industry. Another event that we did was NASA in the Park. This was recently. I think this video will load. We were just having fun there. So we showed...
Yeah, this would be really fun for one of those.
I forgot to take the audio off of that, but... So we got to interact with people of all ages and just engage with the community about what we do, what the opportunities are in Huntsville within the space industry. And then, this is today, right? The Huntsville City Football Club has asked us to present the soccer ball. Yeah, the what? The game ball at the game tonight at the Huntsville City Football Club. Unfortunately, we can't be there, but other members of our team are there with the rover today. Is this you, Will?
So I want to spend a little bit of time talking about our support from UAH, because this program absolutely could not happen without the wonderful support that we have from our university. So a big part of that is going to be our facilities. So we have a variety of different facilities, UAH being, again, a Tier 1 research school that allow us to have the capability to do what we do here. One of those is our machine shop. That's the biggest resource by far that we have. We have our access to our machining, general shop tools, and it allows us a good assembly space where we have a lot of common tools so that Moonbuggy as a program doesn't have to own every single piece of equipment that we need. That would be totally cost prohibitive, but we as a university are able to collaborate and share with those things and also learn from each other across different teams in that respect. We have our Moonbuggy room, as we're calling it, and that is a dedicated space from the university where we're able to store things. Different assembly and tools becomes a big help. And we, of course, have our Moonbuggy classroom, which is where we do our meetings, and I'll touch on those a little bit more. Our machine shop is, again, an absolutely wonderful resource. We have a really world-class machine shop manager who did all kinds of absolutely amazing things in industry, and it's just a really great place. It supports all of our university research programs that actually have to develop prototype parts. Those will be developed there. And it even allows for personal projects sometimes for students when they have things that they're interested in, they want to work with, they can pair up with the shop manager to see about doing that. So some of the tools that we specifically use are, we have 3 manual mills, which are manually controlled but also have a computer interface for cutting more complex shapes with a human control. We also have 3 manual lathes, again, a similar configuration. We have 1 CNC lathe, which is fully programmable for very complex shapes and precision, 2 CNC mills, much like the ones that you have here at INTEC that can make some very excellent parts, very complex, vertical band saws, horizontal band saws, presses, various shop tools, and also workspaces. And again, a little bit more about our shop manager, Mr. John Buckley. He has really become an integral part of our team. It's really important to us that we're not just a team operating. We have support directly from the staff at UAH that work with us. They are really a part of our team, and especially he is. And he teaches the students how to run the machines in the class, how specific parts can be made or held in the machines, specialized manufacturing techniques, all of those things. And there are regular communication, open lines between Mr. Buckley and Mr. Fikes, along with the rest of the team, to see, is this design feasible? Because we're entry-level engineers. We need someone with the know-how to tell us what we can do. A little bit about our machine shop program. This is very important to us because this is what allows us to actually get the work done every day, because I can tell you that we were in there for quite a long time machining, some very late nights. I see some grins across the room of some of the other HERC teams. You know exactly what I'm talking about. So to that point, we have 3 different levels of access. We have white card, which is you are safety trained and you have general shop access to the basic tools that you may need to go about your day, drills, things like that. And that gives you 9 to 5 access Monday through Friday. But you have to be, there has to be someone in the shop who is certified above you to make sure that you're taken care of and giving respect to the safety rules. The next level of access is our red card, which means that you can use general shop equipment and the machine shop. So this is what gets you on the mills, the lathes, the heavier equipment that carries somewhat more risk and cost. So we have extra training for that. And that is an excellent resource. It's what all of our machinists on our team are red card certified, and that allowed us to be in the shop 7 a.m. to midnight, 5 days a week. And we can also supervise some of our white cards who can accomplish some of the easier tasks for us. So that allowed us to get, I think every single person on the team at some point was in the shop contributing to our construction, which was a huge deal for us to actually get everyone with their hands on the moon buggy. And you acquire that permission by passing the MAE 115 class, which is what teaches you the machining. And finally, blue card is a little bit like red card, but you just get longer hours. It requires you to be certified with medical training. Should there be an accident in the shop, you can take care of that. And you have to have a good bit of experience to get that. So we only have a few of those, but they are certainly a great resource when we have to pull in on weekends, when the shop manager can't be there, just to make sure that we're being extra safe and everyone is allowed to work, but we're also in a safe environment where we can be confident we're not going to have any kind of hazards. So what is MAE 115? Well, this is, again, UAH's basic machine shop training program, and this is one of the most excellent resources that we have at this school. It's not a degree requirement of mechanical engineering, but it is, I think, one of the best classes that I ever took, because it's not just about making you a machinist in a way that a technical program trains you to. It's an engineer's machine shop. So they're going to go through the theory behind what's actually happening with those cutting tools, the thermal expansion of the metals when they're being cut, the coolant, all of these different things, gear ratios, all of that is being pulled in and actually showing us how, as an engineer, can we look at a part and say, this is a good part, not just from a design standpoint, but we can make this. It is actually manufacturable, because engineers have been known to make impossible parts before. So that's actually manufacturable, and is it efficient? And I'll turn it over to Carissa.
Thank you. So another one of the really great resources that UAH provides to us is our moon buggy room. This is a room that is directly adjacent to the UH machine shop, so we have quick and easy access to our storage and our moon buggy specific tools. They provide this to us so that we can have a space to store our rovers and have a space that's not necessarily just out in the machine shop where we can have the rover sitting while it's in the assembly phase. We like to have this room so that we don't have to have the rover necessarily sitting in the middle of the machine shop posing a safety hazard if it was sitting on jack stands or something like that. Another facility is our moon buggy classroom. This is where we have our class meetings, and we meet every, this year, it was a 2-day-a-week class, so Tuesday and Thursday for us. We came in and we would go through the status of the project, different homework assignments, and what we needed to get done. This also gave us a really great space for collaboration. Moon buggy is so collaboration focused, so we really need a really always available space where we can come and talk about the project. Another really great resource is the UAH practice course. So we actually partnered with UAH Building and Grounds so that we would have the permission to build a practice course on UAH campus. We did this with some dirt we purchased, some rocks we purchased, sand. We built the obstacles based on the specifications on the HERC handbook, which participants may know. You don't know what you're going to expect when you get to the competition. You want to be able to test that rover before you get it there. In addition, we also had the entire campus available for our riders to ride across. There was a lot of times we would see our riders riding, 2, 3, 5 miles around campus. We have a Frisbee golf course that is very off-road and rugged, a very good simulant of the course itself, and it prepared them for the athletic challenge. These are some photos taken around our campus of places they were spotted.
So in the competition, there were obviously a few different stages. This was more about our actual in-the-ground work that we did. So very early on, we decided that the process we wanted to go forward was to split our group into 5 teams so that each of those design teams can focus specifically on making that subsystem the best product that it can be, and we were all responsible for making sure that it interfaces with the other systems. So that was suspension, wheels, drivetrain, frame, and the steering mechanism. And to make sure that everything was headed off, we very quickly voted on our team lead and our safety officer to make sure that we had those administrative roles in place, and that, of course, is a NASA requirement as well. So each of the sub-teams had a lead which would report the findings and the workings of each of those teams and be responsible for the progress. So that gave us a chain of command and accountability that allowed us to get through challenges. So in the design phase, we spent a lot of time on Fusion 360, which is a computer-aided drawing CAD program, and it allows all the users to work independently on their own computers, and it uploads the design to the cloud so that we can all access it at the same time and make necessary changes. We had weekly all-hands meetings, as we discussed earlier, to make sure that we were all updated and tracking on the same thing. We had to input our design choices, our requirements verifications, and our plans that were recorded. And we performed finite element analysis on all of our critical components to ensure that they were safe, they weren't going to fail, and they would perform as we were going to expect, but also that they were optimized. Fabrication, we started this as soon as possible because fabrication does take a long time. We're very proud to say that we ourselves manufactured almost every single part of the rover, other than a couple of little pieces we had to have a little bit of help from our machine shop manager after we made a few attempts at it. We began machining as soon as our stock arrived in a few weeks after the first week of class. We were welding for all of the subsystems from November through just before the competition, about a month out. And we had various different manufacturing processes that we used as well. Our drawings kind of help us keep track of everything. They give us, as machinists, a picture of what we're actually making. This is a high-level drawing of the rover, but that's how we machine our parts. We have our file up and we look at that and make it from that. But also it was important to have these because we were able to do some of our requirements verification before we ever even had a physical rover. So we were able to test the turning radius just in this model to ensure that we were actually compliant with the NASA standards, and also our ground clearance we checked in the CAD model. So we were confident before we weren't going to get to a built rover and then have a problem. Assembly took quite a long time. There's always little things you don't anticipate when you start putting everything together. So a lot of that process was us bringing our parts in that we had made, putting them together, testing it, something breaks. We go back, address that, fix it, test it, something breaks. We fix that again until every part of the rover could function in any of our severe load cases. And so that's a very important part of the process, as you all know. And this was our initial assembly mock-up, what we were looking at before we ever had any parts physically made.
So one of the larger parts of this project was our STEM outreach efforts. These took quite a bit of time as we would travel to local area schools and present activities that were hands-on science, technology, engineering, and math educational activities. So we focused on, rather than making sure that they have an in-depth understanding of some niche topic, we wanted kids to come away from these activities knowing that science and engineering are fun and are something that they can do themselves, that this is an opportunity for them. Many of our activities we based off of pre-planned activities from the NASA Jet Propulsion Laboratory Educators website. We did this because we knew that these were topics that NASA thinks are important for children to understand. And we also connected these to their educational curriculum by communicating with the teachers to understand what are their kids learning in class and how can we make an activity that shows them those concepts in the real world. So we talked about concepts like the laws of motion, the engineering design process, and energy transformations. So our activities that we had were astronaut landers. For this activity, they had to design a vehicle where their astronauts, which were really marshmallows that they always wanted to eat, how can they protect their astronauts when it's dropped from a great height? And when they're this big, this is a great height. Paper airplanes. We showed students how to make different types of paper airplanes and then challenged them to improve upon these designs to make them fly as far as they could. Students would compete to see who could create the best paper airplane. And then similarly, they made straw rockets. So they would make a little paper rocket and then launch it using a straw. This taught them concepts about the basics of aerodynamics and then the engineering design process. Additionally, you can see in this bottom corner, we would bring one of our older rovers to the campus and let the kids see the rover hands-on. This was always very exciting for them because they go, whoa, it's a real moon buggy. And they always love to get their pictures taken on it. So I'm going to turn it over to Eli to talk about rider selection.
So with our HERC team, we wanted to make sure that everybody on the team had the opportunity to, if they wanted to try to be a rider. So we opened it up to everybody initially. We had about 10 people of the 32 that were interested in riding. And so everybody had the opportunity to ride the rover, and after several months of people riding around, we sort of whittled it down to a couple of people, and then from there we had an internal discussion between all of us of who we thought was going to be the best rider based off of how they worked with other riders and how much effort they put in and how productive they were at riding. And so after we decided all of that, we ended up with our two teams, me and Rosa as being our primary riders, and then our secondary riders. So on the competition day, we obviously had the goal to win, but there were many steps that we had to take in order to get there. So the first of them is that we made sure to stretch because we want to stay safe, and that's our #1 priority. The other is we made sure to go ahead and plan ahead of time, and so we got there very early in the morning before any of the teams started riding to make sure that we fully understood what the course was like and how we were going to sufficiently go through it. And then we also, since we're stressed because it's competition, we made sure to stay calm but also to have fun. And then very importantly, along our whole way, we had our team cheering for us, along with other teams from other countries and other schools cheering us on as well, especially you all. And here are some of the photos from the competition, just showing off sort of the rover and our time and experience at the competition.
So we wanted to tell you a little bit more about our experience in Moonbuggy. Every year, we have a brand new team. This is something that comes with having this as a class instead of a club, and there's some really good advantages to it, but there's some disadvantages as well. Some of the advantages are having a fresh perspective every year with a brand new group of people, and we really allow some unique rover designs to come out of UAH. You have a brand new group of people with new designs and have fresh perspectives. And we can maximize participation by having a new group of 32 students be able to participate every single year. So we're getting a really high number of engagement, and it encourages new outstanding talent to emerge. Some of the disadvantages include losing experienced team members. We don't have that year-to-year experience going across because we're losing the entire team at once. We have to spend more time learning about the program because of this. And we have inventory management challenges. You have one group of people who are storing things one way, they know where stuff is at, then those people leave, you don't know where stuff's at anymore, so you spend 2 weeks at the beginning of the year figuring out what you have and what you need to order. And we also have some complicated maintenance of old rovers. All these old rovers that previous teams built, we don't know much about, and so we really have to reverse engineer and figure out what they did in order to fix them. And I know INTEC talked to us about them doing some rover fixing, so it's a shared experience. Moonbuggy really is a project for everyone. On our team, 4 of the 32 students are non-traditional students, meaning that these are students who pursued a different life path before deciding to return to college and get their engineering degree. 18% of the students on the team reported as a race other than white, which in Alabama is the primary race. So we really want to involve everyone in the project. 9 of the 32 team participants are women on this team. This was something that was really big for us. We want to increase the number of women in STEM fields and show what we are capable of through leadership. 28% of the team is a big difference from the 18% that UAH is in the engineering college. UAH engineering is very dominated by the males, and so we really like to show what we are capable of. All of these different diverse skill sets and perspectives really make Moonbuggy great. Our video is not loading, so I'm actually going to skip through this slide. I'm going to provide it to the INTEC team, though. Will?
So Moonbuggy really transfers over to real life skills, and one of those is a job interview. I can say for myself, the reason I have the job that I do now is because of what I could talk about my experience in Moonbuggy. So we're developing really important things like leadership. Our technical experience is really shown well through the things that we develop, and that is an excellent resume builder because you can talk about something you've actually done rather than just things that you've learned. And projects are a huge deal to industry, so that's very important for you graduating. And, of course, communication and presentation, a big part of engineering that's often overlooked, as I mentioned earlier. That's a really good thing that we cultivate within this program.
So I'm going to talk a little bit about my current internship. I got this internship mainly because of my participation in Moonbuggy. My participation in this group allowed me to sharpen my skills for the workforce. So I'm working as a stress analyst support intern at Hexagon ALI. This is the company that produces the program that we used to do our stress analysis on our rover. So using this technology, I was able to talk very competently about how it's used, how to support this program during that interview. Additionally, I got to work on my public speaking skills, which helped me in this interview because I had to talk to a panel of interviewers. So because of my experience in Moonbuggy is what allowed me to get this job, and I think without it, I would not have had as good of a chance as I did.
So a big part of the HERC program is transferable skills to the workplace. Some of the skills that we use in the HERC program are key skills that we as engineers need in the workforce. These are the CAD experience we do from our design process, the systems engineering processes that we follow throughout our project lifecycle. We also apply finite element analysis, which is a very big part of modeling and simulation for structural analysis. And we also do technical writing and physical interface management. For me, this technical writing and interface management has been one of the most helpful things because managing a complex project is a very difficult task. And by participating in HERC, I was able to get that experience before entering the workforce. So to summarize, Moonbuggy follows an entire engineering lifecycle. We go from proposal to design, to documentation of the project, to assembly and testing, to operation, and finally, closeout. Closeout is what occurs after the project is over, so we are currently in the closeout phase. We'll finish up all of our documents from our team's year and ensure that next year's team has access to these. I want to take some time to share our favorite Moonbuggy memories with you. One of these was surprising Mr. Fikes with painting our rover blue. This was something Fikes did not know was occurring. We also did not know if it was occurring either because of assembly challenges. However, we were able to get it done about late February in order to have time to paint it. Another was climbing High Butte for the first time. I'm not sure if these videos are going to load, but it was a really big point of success for us. Sadly, I don't think they will, but the INTEC team who toured UAH got to see it climb High Butte and know how big that slope is. It's about 6 feet tall. For me, my very favorite memory was finishing our design review and our operational readiness review. I probably put 120 working hours into those two documents, and so having those finished and closed out was a breath of relief for me. I really put a lot into these documents, and so did our other team members, so winning the project review award really made all of that time and hard work worth it. We did not even realize the project review award was a thing, or at least I personally didn't, so whenever they announced that for us, I cried tears of happiness. Another great memory is Alabama Space Day. For this, we had to take a road trip down to Montgomery, Alabama, so it was a really great time for the team to do some bonding and take some really cool pictures, as you can see here. Competition Day was probably many of ours favorite memory. Seeing all the teams come together and talk about STEM, talk about the shared challenges that HERC teams face, it was really something special. And we got to spend a lot of it with our team as well, showing school spirit and spirit for our country. And I know the Dominican Republic teams, they did that very well. They won the Spirit Award. That was awesome. Oh, my video's not loading here either. Okay. So how did we get here to the Dominican? We met the Dominican Republic teams at the competition this year. We met INTEC, and through this relationship that we established, we were able to come here and talk to you guys about how we run our program, about what Moonbuggy means to us, and we really want to help expand the program. We'd like to thank you again for the opportunity to come here today and present with you. We'd like to give a special thanks to Ezekiel and his team and everyone who has really made our experience here amazing so far. And we'll now take questions. How would y'all like to run this? Would you like to get questions from the crowd? Okay.
Bien, gracias al equipo de la Universidad de Alabama en Huntsville por contarnos sus experiencias, todo lo vivido como parte del proyecto Moonbuggy y su experiencia, y pues destacar, como bien mencionaban, las cualidades de cada uno de sus integrantes es precisamente lo que les ha dado el éxito en dicha competición. Así que felicidades por ese primer lugar y gracias nuevamente por acompañarnos. Un aplauso nuevamente. Bien, ahora vamos a realizar una ronda de preguntas y respuestas. Vamos a tener a nuestras traductoras para facilitarles en caso de que alguien pues tenga problemas para comunicarse. Tendremos esa facilitación en este momento. Si alguien tiene alguna pregunta para el equipo, ya sea un estudiante, alguna de las autoridades.
Hello. I would like to ask about the work-life balance of managing such a challenging project like the rover. No.
This one's fun. Okay, yeah, so
Is it something at first that's troublesome and then you learn how to be better at it, or is it something you have to learn on the spot?
work-life balance has really been learned through our entire engineering program. We start freshman year coming out of high school, not super prepared for college workload, but we quickly learned to take that on. And with Moonbuggy being a class for us, this was really easy to just translate right into the Moonbuggy project. So a lot of us treated, I'm sorry? A lot of us treated Moonbuggy just as any other homework assignment, so we would allot time for it and do it that way. And I know me personally and many of us, we also worked co-ops during our time, or internships, during our time in the Moonbuggy program and in school. And so we really had 3 different things we were balancing between school, work, and Moonbuggy. We always like to say Moonbuggy's a second job for many of us. But yeah, it was really something we learned going through the program at the beginning of the year. It kind of felt a little bit overwhelming, but we slowly learned how to accommodate our schedules for it and be able to meet all of the requirements that were asked of us.
So this started as a homework and then it snowballed into the Moonbuggy.
It's not really that it started as homework. We just treat the project assignments as homework. So at the beginning of the year, we joined the Moonbuggy team. And the work that we are doing to see the project through, that is our homework time we would spend on that class. We're getting class credit for this, which means that we have some time that we can spend on doing homework for that class.
Thanks.
Yes, of course.
Hello, good evening. First of all, thank you for your presentation. It was amazing, perfect. It was very well done, very well communicated. Space economy will be maybe the most strong industry in 21st century. By far, U.S. is leading the industry because you are the head, actually, of the space program. In your specific 4 cases, do you have any idea on which sector of this industry will like to be, or you have any idea of make your own company for taking the piece of a cake of that big budget that will be in the space economy? Thank you.
Yeah, well, I know all of us, we all live and work in Huntsville, and I personally work in aerodynamics, which is, very related.
Yeah, so I currently work in stress analysis, and I'll, in the future, be transitioning more to a materials-based role.
I currently work in project management, so sort of a more systems engineering.
And I do a little bit more of a programming side, aerospace data analysis, which is also very applicable.
So I'm not sure if any of us would ever start our own company, but, we would love to if we had the time.
Yeah.
But yeah, to answer your question, we all are going into the workforce. I don't think any of us have any plans right now of starting out on our own, but maybe in the future.
But the big thing to us is we're all able to use this experience and actually contribute to that body of knowledge, each in our own perspective ways, because it's a really lofty goal, the idea of the Artemis missions and space travel and space industry. And it's a really special thing that we're so blessed to be in a part of our country and you in a part of yours where you're making a meaningful, good contribution to that, and will continue for the next generations.
Gracias al equipo. Bien, por un tema de tiempo, no vamos a extender esta ronda de preguntas. Sin embargo, los chicos de la Universidad de Alabama van a estar toda la mañana con nosotros. Al final también ustedes se podrán acercar a ellos. Y en las próximas rondas de preguntas, pues quizás también tendrán la oportunidad para, pues, confirmar sus dudas, preguntar sobre experiencias y demás. Con un fuerte aplauso, entonces, despedimos del escenario a Carissa, Rosa, Elias y William. Muchas gracias. También permítanme saludar a quienes se integraron a esta jornada. El mayor general técnico de aviación, el señor Carlos Febrillet Rodríguez, de las Fuerzas Armadas de la República Dominicana, comandante general de la Fuerza Aérea de la República Dominicana. Y entre nosotros también se suma el presidente de Cooperativas Reservas, el señor Robinson Portorreal, que como ya dijimos es el patrocinador oficial de esta visita. Bien, antes de continuar con la segunda conferencia, que será pues probablemente el plato fuerte de la mañana con el director, con uno de los directores de la NASA, hemos habilitado micrófonos, radios, mini radios, para quienes no comprendan el inglés. Entonces, al salir, pueden solicitar entregando su cédula. Vamos a dar 5 minutos para quienes pues tengan problema con el idioma, puedan hacer esta solicitud del radio y así entonces comprender todo lo que el director de la NASA está por compartir y luego posteriormente también el señor David Fikes, quien también tendrá una exposición. Entonces damos 5 minutos, vamos a respetar el tiempo. También si entienden perfecto, pues se pueden ahí mismo estirar un poco, parar de sus asientos y en 5 minutos estamos de regreso. Al salir justo, a ver, si es en dirección a la puerta, pues sería mano izquierda. Hay una joven, le pueden entregar su cédula, recuerden. Invitamos a que por favor vayan tomando asiento para continuar con el desarrollo del programa.
Que se puede sentar y que los que tengan preguntas al terminar con Kevin, vamos a abrir ronda de preguntas para Kevin y para el equipo también.
Okay. Ya se entregaron todos. Como ya todos han ido recibiendo sus audífonos, invitamos nuevamente a tomar asiento. Recordamos que luego de la participación del señor Kevin McCah, pues tendremos otra ronda de preguntas donde podrán seguir la interacción, al igual que con los chicos de la Universidad de Alabama.
I don't know. Can you all hear me?
Bien. La próxima conferencia le corresponde al señor Kevin McCah, director de la Oficina Regional del Sureste de Participación en STEM de la NASA. El señor Kevin obtuvo una licenciatura en Ciencias Políticas de la Universidad Estatal de Morgan en Baltimore, Maryland. También es graduado del Programa de Desarrollo de Supervisión Láser de la NASA, el Programa de Liderazgo de Nivel Medio y la Serie de Desarrollo de Liderazgo de Marshall y de varios programas. En el año 2020 fue nombrado como el primer director de la Oficina Regional del Sureste de Participación en STEM de la NASA, donde lidera un equipo de profesionales encargados de sumergir estudiantes en el trabajo de la NASA, mejorar la alfabetización STEM e inspirar a la próxima generación a explorar. Se encuentra de manera virtual, and even though you couldn't be here with us physically, we are so glad and honored that you can join us, that you have been able to join us. So from Dominican Republic, our deepest greetings. Y con un aplauso, pues le recibimos, que esperamos que lo escuche.
Good morning, Dominican Republic. How are you all doing today? Hey, okay. I can hear you, but I can't see you yet, but that's all right. Listen, I want to thank you all. I want to thank you all for giving me the opportunity to spend a little bit of time with you this morning. And I want to express my most sincere regrets for not being in the room with you today. We worked very, very hard to try to get to me being there. In fact, in the United States, I've traveled to the Dominican Republic many times on my personal passport. But when you travel as a representative of NASA, you have to have a special issuance government issued passport in order to travel. And so we went through all the hurdles of getting the government issued NASA passport. And then just as we thought we had everything addressed and we were ready to go, we found out that we needed some additional country clearances from the State Department. And we weren't able to get that done in just enough time for me to get there. So we had to cancel my travel arrangements, and I have to connect with you all via Zoom. So please accept my most sincere apologies. I am disappointed that I'm not there in the room with you all today, but hopefully I'll get a chance to talk to you all a little bit and take some questions and share with you why what you all are doing there in the Dominican Republic as it relates to STEM engagement is so important to the country, so important to the world, so important to the space program. Does that sound good? Can we talk a little bit? All right. I see a few heads nodding. Hey, so as she mentioned, my name is Kevin McGaw. I work in NASA's Office of STEM Engagement. We call that OSTEM. And it's a long title, the Office of STEM Engagement, but we've got a real simple job. Our job is to connect students with NASA missions. It's that simple. It is all about how we get students engaged through student challenges, internships, grants, all kinds of things to get them engaged and involved in NASA programs. And that's a pretty cool job, huh? It's the best job I've ever had, I got to tell you. And my role is to coordinate the STEM engagement activities in the Southeast, what we call the Southeast region. It's really Marshall Space Flight Center in Huntsville, Alabama, and at Stennis Space Center in South Mississippi. And NASA has a rocket factory. I don't know if you all are aware of this, but the MESCyT assembly facility in New Orleans is where we literally manufacture the rockets that we are going to be flying in the Artemis mission that I'll talk about in just a little bit. So that's my job. I lead these teams of folks who are super passionate about connecting students with NASA missions. It's just that simple. At NASA, we are all about discovery, exploration, and pushing the boundaries of what we know, expanding our knowledge of the universe and our place in it. And that's why I'm so excited to talk to you all today about the importance of STEM and NASA's work in science, technology, exploration, climate research, and so many other areas. And so I want to tell you, NASA is involved in this really, really difficult mission. We call it the Artemis mission. And to be very clear with you, NASA is on the mission to put the first person of color and the first woman on the surface of the moon. Not just like we did in the 60s where we planted the flag, but we're going to be on the moon, living and working on the moon, understanding how to live and work on another body with the intent of springboarding on to Mars. Now, that is no simple task. It's a huge, challenging task. We call it the Artemis mission, and we are not doing it alone. We have international partners who are working with us, and we call these countries that are working with us, we call them the Artemis Accord countries. 43 countries across the world engaged with us as we endeavor to put the first person of color and the first woman on the surface of the moon. Now, and I will tell you, to you all in the Dominican Republic, we had some conversations with the ambassador to the Dominican ambassador to the United States, who joined us here in Huntsville, Alabama, just a few months ago for Rover Challenge, and we're looking forward to, at some point, the Dominican Republic joining us in those Artemis Accords. So I just want to share with you that NASA's work is not just only about NASA. It is an international partnership that we have with a number of countries. And so I talk about the Artemis mission. Well, you students that are in the room, if you are a student, they were able to turn the camera around a little bit so I can see you all just like you're looking at me. So if you are a student, let me see you raise your hand. Ah, there you are. Good. Now, I want to tell you how we refer to you all. At NASA, we refer to you all as this rising generation of STEM explorers and discoverers, and we call you all the Artemis generation. Just like there was an Apollo generation and an Apollo mission that took place back in the 60s, this era where we are today, this is the Artemis generation. You all are the Artemis generation. And long after I am more gray, you see there's some gray in here now, when I'm more gray and I'm covered in gray and I'm retired and I'm at home in my rocking chair, you all will be the ones who are helping us truly get on from not just the moon, but into deep space and on Mars. And someday we will have a permanent presence, human presence on another planet. And we're really excited about you all and passing the torch to you all and preparing you all for that opportunity. Now, every opportunity that you all take as students to explore new paths and enhance your STEM skills and develop your leadership abilities, some of those same abilities and STEM skills you just heard some of the UAH students talking about. Every time that you're expanding those skills and developing those skills, you are preparing yourself for these really challenging adventures and challenges that we have to come. And so we're excited about you continuing to develop those skills. I need to congratulate, thank, and acknowledge a few people who are there in the room and who have been involved in this whole effort. Some of them have been instrumental in the teams from the Dominican Republic participating in NASA's Human Exploration Rover Challenge. I'm going to talk to you about that in just a few minutes, but let me first recognize a few folks. So first, I want to recognize and thank Ezekiel Diaz. Is he there? Let me see it. Where is he? There he is. All right. I want you to wave at me because I want you all to know that Ezekiel has been critical in the engagement of many of the folks who are participating in today's conference. And so I want to thank him and his flexibility as we were trying to work through getting me here, getting me there to the Dominican Republic. Second, Robertson Porto Real, president of the National Government Bank, who's one of the principal sponsors of the event. We want to thank him. I want to thank Arturo de Villar, Vice Rector of INTEC University. So happy to have him. Also, Cayetano Rodriguez, Dean of Engineering. I want to thank them for being here. Yes, sir. Good to see you. And I want to tell you all, if I could, I would be right in front of you sitting in that empty seat on the end. I'd be shaking you all's hands and speaking with you all. So, and I pray that in the future, I'll have a chance to meet you all in person. I want to thank General Fabriet, Commander General of the Dominican Air Force, and all the generals and colonels from the Ministry of Defense and the Aeronautical Department and the Aerospace Department of the Dominican Republic. There are some representatives from the university there, INTEC, and other universities. I want to thank you all for all that you all are doing. Truly appreciate all the work that you all are involved in. I want to thank the 6 NASA HERC teams, Human Exploration Rover Challenge teams from the Dominican Republic. If you are in the room, you know how you remember me, right? You know I like to get you all to make a little bit of noise. So if you are one of the 6 NASA Human Exploration Rover Challenge teams, I want to hear you make a little noise. I see you. Listen, you guys are why we do what we do, and so I want to thank you. And I also want to recognize the NASA winners of this year's competition, the UAH team. And I got a chance to sit in on your talk just a few minutes ago, and the future, we are in good hands with all the many students who are involved in these programs. And UAH, you all did a great job in your last presentation. Hey, so I love having the chance to inspire students and encourage them to picture themselves in STEM. And one of my favorite parts of my role is having the opportunity to speak to some of the most talented and dedicated young people and help shape their future. And so I am particularly interested, I will tell you, I have a genuine passion for people of color being engaged in the space program. That is a big deal. As someone who attended a historically Black college, Morgan State University, you heard about earlier, it's in Baltimore, Maryland. It's what we call an HBCU in the United States. It's historically designed, created for Black students in the United States, when many Black students never had a chance to get an education. In the late 1800s and the early 1900s, a series of Black schools were created so that African Americans could be educated. And so I have a passion for seeing Black and brown people, people of color, engaged in education, particularly when it comes to STEM. And so we have a number of examples of Latino and African American astronauts and figures that are engaged in the space program. And me personally, I believe that representation matters. It matters when you see people who look like you engaged in leadership positions in STEM, like Jose Hernandez, an astronaut, Joe Acaba, an astronaut who had some exposure and experience in the Dominican Republic many years ago, Charlie Bolden, who was the NASA administrator. Some of you all may have recognized that name. He was a NASA administrator many years ago. And if you don't know, even at the early stages of the space program, people of color were involved and critical to the success. There's a movie called Hidden Figures. Have you ever heard of that movie, Hidden Figures? See a few people nodding their head. If you haven't, make a note to take a look at this movie, Hidden Figures. It is about women, African-American women in the 1960s who were critical to the space program. I mean, they were instrumental to our work in the Apollo program. And so not just people of color, but for women, we really want to be aggressive and proactive in engaging women in STEM. We know that ultimately, if we have all of these different perspectives, we have the best chance of solving some of our most difficult problems. So in the US, I need to tell you, and this is why it's so important that we engage students from underrepresented groups, people of color, women. Women make up 51% of those with college degrees, but when it comes to science and engineering, that number, that percentage drops down to only 29%. And when it comes to engineering, we are told that women make up about 16%. So we have a lot of work to do to ensure that we are pulling everyone in. Same kind of similar numbers exist in the space program with people who are of color, people of color. And so we've got a lot of work to do. And I need to tell you, it's not just because it's the right thing to do. Data is clear. If we pull in people with diverse backgrounds, who've experienced different things, they come from different areas, culturally, they solve problems differently. When we tackle the most difficult challenges with all of these creative solutions from over here, a young lady from the Dominican Republic, a young man from India, someone else from Hawaii, from the US, and from South America, and all over the world, when you have all of these folks contributing to the solutions, we come up with more creativity, and as a result, we have better solutions to our problems. Does that make sense? Okay, so that's the reason why NASA is so proactive about trying to broaden student participation. It's a big, big deal for us. And so I want each of you, particularly the students, I want you all to know that STEM includes you, and you bring something unique to the table when it comes to STEM, and that you belong in STEM. You belong in STEM, and so I want to encourage you to continue to pursue it. Now, you generally think of, when it comes to STEM, you generally think of astronauts and engineers, right? I mean, that's just what when you think of NASA, at least in space, I'm sorry, when you think of space, you think of astronauts and engineers. But there are many, many other careers that are STEM careers that contribute to the space program that aren't just astronauts and engineers. So I want to encourage you on YouTube, if you would do a search for surprisingly STEM, a search for surprisingly STEM, you will find a whole host of really cool, interesting STEM degrees that aren't necessarily astronauts, but they were instrumental and are instrumental in the space program, okay? So really want you to take a look at that. So the other piece is, you know, oftentimes people think of scientists and engineers and people involved in STEM as being less creative. And so I want to dispel that for you right now. As you pursue your STEM degrees, as you pursue opportunities in STEM, don't let people say, oh, you're an engineer, you're not creative, or oh, you're an engineer, you're boring. That is not the case at all. And speaking of these unique ideas, there are a tremendous amount of creativity that exists within the STEM fields, right? And so all discoveries begin with a spark or an idea, how to overcome a challenge, designing a new tool, a new process, building it, bringing it to life, and that is creativity in action. So innovation and creativity, they go hand in hand, and they are critical in STEM. So STEM professionals are very creative and very innovative. Hey, I want to just hit you with 2 more points, and then I'm going to get off the stage and let you get back to your event. I'm sorry for taking too long. I'd like to talk to you all a little bit about STEM in our everyday lives. So when you think of technologies in STEM, it's not only about just advancing the space program. The technologies we use, yes, they do indeed advance the space program, but they oftentimes have spin-off technologies. They are things that we can use in other spaces. I'll give you an example. James Webb Space Telescope. The technologies that developed the James Webb Space Telescope, a space telescope that NASA is using to look into the farthest reaches of space, that has led to improvements in LASIK eye surgery, helping people to see better. See, so the things that we're doing in space aren't only for space, but they have real world applications and spin-off that could actually make our lives better. And it's not just the technologies, it's also around Earth observation. We have a constellation of satellites that are studying the air and land and water, focused on changing the climate and ways to address how we predict severe weather, our atmosphere, and even natural hazards and disasters that can be caused from hurricanes and wildfires. All of these things are things that we learn from the space program, not just human exploration. Yes? So we need to take a lot of good care in encouraging our young people to pursue activities, pursue academics in STEM. We're super excited about many of you all pursuing those careers. And I asked earlier if those who are in the room who have participated in HERC could raise their hands. The reason why I wanted to do that is if you are interested in activities in STEM and you think what you've heard today from the UAH team, what you heard me talk about around HERC or Human Exploration Rover Challenge, and when you hear us talk about moon buggy, those are the same, okay? I just want to make sure you understand. We used to call it the Great Moon Buggy Race. It is now called the Human Exploration Rover Challenge. It is the same competition. We've just evolved it because the moon buggy race was focused on what could be the moon, but we may be developing rovers to travel other places like Mars, right? So we just evolved the name of it. It's the same competition. Those individuals who've been involved in the moon buggy race, or what we now know as Human Exploration Rover Challenge, I ask you to put your hand in the air, because if there are other students in the room who want to know a little bit about what that experience is like, I want you all to know where to go, who to talk to about that. Now, we have this effort, this Human Exploration Rover Challenge. I'm partial to it. I love it. I think it is amazing. We have a number of student challenges, but HERC, Human Exploration Rover Challenge, is one of my favorite. And there is this one country that particularly, we have 12 countries in addition to the United States that participate in Rover Challenge, come from all over the world. But there's this one country and the teams from this one country that have more excitement, enthusiasm than any of the other countries that come and participate. And I bet you all may know which country I'm talking about. See a few heads nodding. I've got a video to highlight to show some of the highlights of this year's competition. And so I'm going to share my screen and show you a quick video. Do I have enough time to do that, Ezekiel? Okay, all right. I'm going to share my screen. At least I'm going to try to. Okay, I think I've done it. Do you all see? Can you all see something? Do you see a team on the screen here? Do you see something? Okay, I'm going to play this. I want you all to see this. Okay. So you see why the NASA is so excited about having the Dominican teams participate in Human Exploration Rover Challenge. You all bring such a spirit of excitement and enjoyment to this competition. I want to apologize for not being able to be present. I was talking to my wife. Ezekiel doesn't even know this, but I have a personal love for the country of the Dominican Republic and the people. My wife and I, we are in the Dominican Republic often. You may not know this, 7 times over the last 10 years have we visited the Dominican Republic. And so we love you all. We love to be, yes. We wish we could be there. I wish I could be there with you all. Hopefully next time I will be. But I want to congratulate all of the teams that have participated. I want to congratulate all of you all and all of the sponsors. In fact, if you are a team member again for Human Exploration Rover Challenge, raise your hand if you competed in the team. Now I also want to have, so that was for the students. But now if you are a faculty member or part of a team advisor, raise your hand. If you are a parent of a team member, raise your hand. Yes. And if you are one of the sponsors that were so critical in making it happen, let me see you raise your hand. Yeah. Okay. Listen, sponsors, parents, faculty members, and students, you all are critical to these teams participating. We are grateful to you for all of your hard work. I'm grateful for the opportunity to speak with you all. And I just need to say this in closing, right? For the students, I hope you all are beginning to see all the ways that your unique mix of ideas and interests and talents can help change the world in the future, particularly around a space program. So don't be discouraged when your paths take a few unexpected turns and twists. Every grand adventure that we take on, every big goal we achieve, we have to do it together. We had a center director here at Marshall Space Flight Center that used to say, if you want to go fast, go alone. But if you want to go far, we have to go together. So I want to encourage you students particularly to be curious, creative, and confident as you step forward in your own STEM journeys. The universe is out there waiting for you. Take it. Thank you all. I think, depending on if there is enough time, I think I may be able to take a question or two.
Yes. Bien, entonces ahora vamos a tener la ronda de preguntas y respuestas. We're going to have a Q&A round. Entonces, aquí, si me ayudan con el micrófono, tenemos una, bueno, allá atrás. Quien vaya a hacer la pregunta para que puedan verse, o sea, para que la cámara los pueda grabar, diríjanse al frente y así entonces... La puede hacer en español y alguien se la traduce.
Thank you.
En el centro.
Hola Kevin, mi nombre es Dariani Cruz, soy estudiante.
Hi, my name is Dariani Cruz, I'm a student.
Hola Kevin, mi nombre es Dariani Cruz, soy estudiante y este próximo año voy a cursar mi último curso de secundaria.
This next year I'm going to be a senior in high school.
Vengo de un pueblo que está ubicado en el borde de la República Dominicana.
I come from a small town that is located at the border of the Dominican Republic.
En el noroeste de nuestro país.
At the north-south of our country.
Se llama Montecristi.
It's called Montecristi.
Yo he venido a escuchar su conferencia.
I've come to listen to your conference.
Y las demás también que es en esta mañana.
And the rest that spoke this morning.
Y me ha parecido muy emocionante, interesante y también me ayuda a mí como persona que voy a también a ir hacia adelante.
It's been very emotional, interesting, and it helps me as a person that's moving forward in this field.
Me siento feliz y privilegiada de estar en este lugar.
I feel very happy and privileged to be here today.
Y también tener estas palabras y esta pregunta a usted.
And then to have these words with you and ask you this question.
Yes.
¿Qué le aconseja a una joven como yo de una zona de bajos recursos?
What do you recommend for a girl like me from a zone of low resources
Que quiere entrar al mundo de la ciencia
that wants to enter the science world
en este tiempo,
at this time,
aquí en un país en vía de desarrollo?
here in a developing country?
Yeah. So I'll tell you my thought. So I get this question often, right? You know, no matter where you are, whether it's in the U.S., outside the U.S., there are those students whose resources are limited, and they want to know, how do we get involved? How do we get engaged in STEM? And so the first thing I would say is, you really have to be willing to buckle down when it comes to your academics, particularly in science, technology, engineering, and math. Really want to encourage you to work really hard, and I bet you've been doing that. So that's the first thing. The second thing is, I want you to be able to see yourself. You should look at and have a vision for yourself in STEM, because you can do it. We need you in it, and you bring unique ideas from the small town that you're in, Monte Cristo. Is that what you said?
Yes.
Okay. So your small town that you're from, there are things and experiences that you have in your small town, challenges that you've had to deal with that you have overcome. And as a result, you have a way of solving problems that's different than the way that I solve problems, right? And so I want you to see yourself in STEM, know that you can do it, work hard. And I would just say to you that when you have your moment, know that you are there because you have earned the right to be there, and don't be afraid. Be proud and stand strong when you get into those circumstances, when you get into the places where you're taking advanced classes in science, technology, engineering, and math, or if you go on to university and you're taking classes, be confident in knowing that you can do it. And by the way, you're at the table because of you being unique. That's why you're there. It's not in spite of, it's because you are unique. So own that, right? And show up and be confident in your space, okay? That's what I would say.
Continuamos, para acá tenemos otra pregunta.
Okay, first of all, thank you very much. It was
Yes,
very
sir.
inspiring for the young students, what the things that you have said. But my question is, in the view of the new space race that is taking place in the 21st century. In the 20th century, the space race was a very tense situation for both countries, US and USSR. But times have changed now. There are things that have been better. There are things that have not advanced that fast. And I would like to know your opinion that if you think that America and its allies will be also win the space race in 21st century, putting a man on the moon first than China. Thank you.
Good question. So, great question. So, there are a lot of people who are involved in the space race, right? There are a lot of countries who are involved in the space race. What we have tried to do is to build some allies in our efforts. And that's why you heard me talk a little bit about the Artemis Accords, the other countries that are partnering with us. So it's not just about the US trying to get there, but other countries who are partnering with us, and we are collectively trying to get there. And so I don't know who will win at the end. I know that we are passionate and committed going forward. We're trying to go not alone because we don't want to go fast. We want to go far, right? And so if it is true that we want to go far, we need to go with allies in that effort, right? And so time will tell, but we're working very, very hard. We're working very, very hard. And, you know, NASA's focus is on the peaceful civil use of space, right? And so, and we love that we have other countries that are joining in and looking at how can we peacefully explore space. So thank you for your question.
Hola.
Hola.
No sé si tenga que ver, pero me gustaría preguntar si
I don't know if this
sé
has to do
de,
with anything, but I'd like to ask.
de algo que se está desarrollando en la zona sur del país para mandar satélites y todo ese tipo de cosas.
We are developing equipment in the south zone of the countries to send equipment,
Y me gustaría saber qué interés tiene la NASA por invertir en el país.
and I'd like to know if NASA is interested in investing in our country.
So in terms of investing in the country, what I can say is NASA has programs and activities that Dominican Republic can participate in. And so in a sense, that is investing. It's creating opportunities for the two countries to work together. And so that is something that we're serious about. I know that there have been discussions at a much higher level than mine about the Dominican Republic and the Artemis Accords. And so we'll see how that progresses. And I think that's probably a starting place in terms of the two countries partnering and working together to advance space.
Gracias. Thank you.
Greetings, Director. It is
Hello.
one of my, I'm a bit nervous, but it is an extreme honor to be able to meet and talk with you. I would like to ask, I'm an electronics engineering student nearing the end of my career. What do you recommend that we follow after we get out of university? What path should we take to be able to follow what we desire?
So I guess that really depends on what you see. First, you have to have a vision for where you want to be, right? And then once you have that vision, then I think you can start to work the steps on what you would need to do to get to that vision. But what I would say to you is getting hands-on experience is invaluable. We talk about that here in the U.S. when we talk to students and they say, what should my next step be? And depending on, so this may not be exactly for you, but I'll tell you the general kind of advice that we give. Gather hands-on experience. Find places where you can get hands-on experience doing research, developing hardware, building metal, and find a really good mentor. Does that make sense? Find a really good mentor, someone in the field that you're interested in, that you can just spend some time with, have conversations with from time to time, pick their brain about how they got to where they are, how things have changed, what they might recommend for you. So seeking hands-on experience, hands-on research is a great one. And two, along the path, and this goes for wherever, anyone there who has some aspirations to be deep into STEM, find a really good mentor, advisor who can help you navigate these challenging waters. Does that make sense?
Yes. Thanks a lot for the answer.
Yes, sir. Yes, sir. Hey, and oh, you didn't tell me your name. Wait. What is your name?
Oh, my name is Eric. I'm a student here at INTEC.
Okay, so Eric, I want to tell you, you started with being nervous. You can't be any more nervous than I am. I'm telling you, I'm sweating up here. So it is, listen, it is okay to be nervous, right? It is okay to be nervous. We all are nervous at times. We just have to face it and still do our very, very best. And you did a great job, man. So thank you.
Thanks a lot, sir.
Yes.
Hello.
Hello.
It's really an honor to meet you. My name is Alba.
It's a pleasure to meet you.
Thank you. I'm a business student, big aerospace and astronomy enthusiast here, and I have two questions for you.
Yes.
The first one is about people who are not STEM professionals and are not STEM students. And I want to know your opinion on how they could get involved in the Artemis project without focusing or orienting their careers towards STEM now.
Okay, that's the first one. You want me to take them one at a time, or you want to give them both to me and I'll answer them together? Your choice.
Yeah, I'd rather tell you after the first answer, yeah.
Yes, ma'am, that's fair enough. Okay, so one of the things that I am struck by at NASA is that, so we often talk about all of the people who have known that they wanted to build rockets, fly on rockets, they want to be astronauts since they were in the second grade, right? We talk about them, and I am amazed by their passion. But I will tell you that we have just as many people who are involved at NASA who are accountants, they're business professionals, they're lawyers, they're in communications, they know acquisitions and procurements, they're administrative professional secretaries. And so we need everyone. We need everyone in this space. We need everyone in this space. And so I would say to you that you don't have to be in STEM to have an impact in STEM. you can have an impact in your country's space program, because every engineer that's out there, they have to talk to someone about how they're going to manage the money. They may not be the wisest when it comes to managing the money, right? And so, so I would say to you, they can pursue their passions, and if their passion is in math and they're accountants, or if it's in law and they're attorneys, there's a way to connect and support the space program, and not only in terms of astronauts and engineers. Okay, and so I'm struck by the passion of those folks, and so I would encourage them to continue to pursue their passions, and they can support STEM and they can support space in their country in one of those other areas, right? But they still support the space program, and they can do that in the Dominican Republic, in any country.
Thank you so much. And my
Yes,
next
ma'am.
question, I know that we have, can you hear me? Okay. I
Yes.
know that we have amazing examples of people from the Dominican Republic that are working with NASA. We have Scarlyn Hernandez, we have Michelle Guzman working there with you. But I'd like to know, how can someone from the Dominican Republic focus their goal, like have a focus on working with NASA? How can a Dominican get to work with NASA?
Okay, so it's a great question, and it's a great question. And so what I would say is, similar to what I mentioned earlier, just do your very, very best in every space and role that you're in. Just do your very, very best. Continue to expand your knowledge, get hands-on experience, look for opportunities. www.nasa.gov. There are opportunities. There are opportunities for research. There may be opportunities for interns. There may be some opportunities for applying for jobs, all kinds of things. And so I would encourage you to use that, identify some of the people that you know have been successful and adopt them as mentors, help understand how they made that journey, right? And so I will tell you, I am looking forward to the day that the first astronaut from the Dominican Republic is somebody who's in that room. And I'll be, that's right. I believe it. They could be in that room right now. And so you just got to continue to pursue your dreams, And then when you do become, to all of you aspiring astronauts in the room, when you do become astronauts, it's okay to say, that guy, Kevin McGaw, that talked to me a long time ago, he's the reason why I'm an astronaut. It's all right.
Thank you so much.
Yes, ma'am. Thank you.
Mr. Kevin, we have one more question.
All right.
Hi, Mr. Kevin.
Hello.
First, I want to thank you for your time. I know that we can feel in the way that you're speaking with us that you truly wanted to be here. So thank you for that. I'm Marcos Diaz, Ezekiel's son. So I have been a little privy to everything that you have been saying.
Mm-hmm.
And my question, simple. I just want to ask you, what would be the piece of advice that you will give to someone who's trying to follow their dreams? Because I believe that you achieved or are achieving what you proposed. So what would be the advice for people like me that just graduated high school, or people that are cursing their university, following their dream? Thank you very much.
Yeah, it's a great question. And did I see you in April?
No, sir.
Okay, well, you know, Huntsville, Alabama is a great place to be in April, particularly for Human Exploration Rover Challenge. I did see your dad there, and I saw my friend who's right on that front row, right there. Yes, you, because he is the one who corrected me in my pronunciation, and I got it right now. I'm doing better now. Yes, sir. Thank you. It's a great question, and so I wish I had some really deep, complex, just really deep answer. But the model that I've lived by, it seems real simple, but the model that I've lived by is do good work. People will notice. I mean, literally, like in my job that I'm in now and the jobs that I've been in before, I just really worked really hard at being as effective as I could possibly be, doing good, really, really good work. And I can't speak for everyone, man, but for me, the way that I've moved and grown in my profession, by the way, it is by the grace of God. I need to say that, right? I don't take credit for it. It is by the grace of God. when I look back over my life and consider where I started from to where I am, I'm super grateful. And I know that I'm blessed, and I appreciate that. But I want to say that people have noticed over my life. And so I didn't have to try to push people out of the way and push people down and grab a hold of this and do that. I just really had to work really hard at doing really, really good work, and people noticed. And so I wish I had something more complex for you than that, but that's my life's motto, man. Prayer and doing good work. People notice. That's what's worked for me.
Thank you very much.
Yes, sir.
Bien, y con esa última pregunta nosotros finalizamos esta ronda. Agradecer nuevamente al señor Kevin McGaugh por habernos acompañado. Thank you very much, Mr. Kevin. We are so glad to have you. And let's make a deal. If you take us to the moon, when you come back to our country, we definitely will take you to the beach, for example. That's the best.
That's a good deal.
So
thank you all. Yes, ma'am. Thank you for having me. I appreciate it. To all of the sponsors and the organizers, to the university, to Ezekiel, to everyone, thank you all for allowing me to participate in this unique way, since we weren't able to get me there in person. Again, last thing I'll say, I know I'm talking too long, but this is a really good example. What we did today is a really good example of what we have to do in life. We've got to be flexible. Right? We have to be flexible, agile, do different things when necessary. Sometimes the world throws crazy challenges at us, and we've got to figure out a way to overcome them by being flexible. And so you all were flexible and allowed me to participate via Zoom since I couldn't get there. And so I want to thank you for that. I hope to be there sometime in the future. So thank you all so much.
Of course, we hope. We hope to have you soon here again, and we're gonna ask you if you can stay with us, connect with us, because the next conference no sé cómo se dice esa palabra ahora mismo, no me viene a la cabeza. Ok, quiere pues decirle algunas palabras.
I want to say some words to you.
Okay.
Así que pues nos quedamos conectados con Mr. Kevin y ahora recibimos entonces
We'll stay connected to you, and now we will introduce
a nuestro próximo conferencista
our next conferences
con el tema Reaching for the Stars, Aerospace Exploration by David Fikes.
Oh, yeah.
Ezekiel, with your permission, I'd like to switch gears a little bit. UH Reaching for the Stars is about the UAH aerospace program. To be honest with you, it's a little bit dry, and it's stuff that you can find on the website. And we have some great pictures, and my team put together some slides, and we'll quickly run through those. But I want to address some stuff that Kevin talked about first, if that's okay. I enjoyed what he spoke about, and I see a lot of female students in the room. And I want to encourage you to reach out for STEM and participate in Moon Buggy for a couple of reasons. When I started with Moon Buggy, basically, that was 7 years ago, basically I had to have a female rider. NASA requirements with a male and a female rider. And so I needed some females in my class. And it was a basic requirement. But over the last 7 years, I have learned some things about women college students. It's very important. And now, well, let me back up and say that. Over the years, I've found that the women students are, as a whole, superior to the male students in STEM outreach. They can go into the schools. The young folks can relate to the girls so much easier than a big old knothead college boy that can't talk to them, because the girls can talk to them, and the kids can relate better, you know, and that's because of moms and babysitters and aunts and grandmothers and stuff like that, you know. And so I have observed that they're much better at STEM outreach. But along the way, I started getting more and more and more female students in my class for the STEM outreach. But what I found, and of course I should have known this because I've been teaching for a long time, that a lot of the women students as a whole, I mean, I've got male students here that are really good too, you know, but the women are better organizers, they are better presenters, they communicate better as a whole, and some of them are great analysts and do great technical work.
Mr. Price, do you want a hand microphone? So
No, it's not bothering me. And now I recruit not just for writers, but I recruit the best students I can find, and about a third of my class is women. It's a bigger percentage than the others in that, because I'm looking for the best. And so I want to encourage you, girls, go for it. We need you. We need your influence. We need your capabilities. Kevin was talking about different perspectives. Well, I have found that the women bring a lot different perspective to the engineering world, and it's really, really important. And there's another thing too, it's called STEAM. They've added an extra letter to STEM: science, technology, engineering, arts, and math. Kevin was talking about we need all people, accountants. We need artists. One of my best friends is an artist.
You're a little bit too tall for that mic.
So okay. And he's been on me for years. You need to get some artists involved with Moonbuggy. And I'm sitting there going, why, Scott? Why do I need an artist? I've learned my lesson. How many of you have ever read an engineering report? It's kind of dry and sometimes boring. We engineers are not good at making life interesting to people sometimes. To other engineers, yes, but not to the world. And STEM outreach is reaching the world and not just other engineers. One of my students, Rosa over there, she got a hold of a document that we were required to present to the Alabama Space Grant Corporation every year that documents our yearly progress and accomplishments. And for the last 7 years, it's been dry and been an engineering report. Well, I didn't know that Rosa had an art background. In fact, she said she wanted to go into art, but her parents wouldn't pay for it because they wanted her to get a degree that she could get a job at Knoxville of engineering. Well, anyway, I'm going to give Ezekiel and several copies of these, but this is our year-in review report. And if you open it up, it's not a dry engineering report. It's got good color pictures, and it's put together in a way that's interesting, and it's coffee table material. Put this thing around, people will pick it up and look at it. Where before, okay, yeah. So I want to encourage what Kevin was talking about women and people from other fields getting into this. It's just going to make our lives so much richer, and I'm so thankful for that. So let's run through these slides real quick here, because I know we're running out of time. But my department chairman helped me put me through these. I hit the button on the right to go. Okay, there we go. This is a little bit about my background. I worked in industry for 40-something years and taught college courses at night part-time. And then I discovered after I got out of engineering and industry that I wanted to go full-time with this. And I thought I might retire and not do anything, but I retired from Boeing 8 years ago and started at UAH. And as long as Moon Buggy program exists, I don't know how long I'll be there, because I really enjoy it. It's the high point of what I do. And I teach other courses too, finite element analysis and that kind of stuff, which are fun, but Moon Buggy is my passion. And I've worked on several things at Boeing and got a lot of experience at that. And the beauty of that is I can bring that industry experience into the classroom and help the students know what to expect when they get on the job. And I try to do that every chance I get. So anyway, we'll go this quickly. So I've done some finite element analysis. That's my other class that I teach, which fits nicely with Moon Buggy for doing analysis. And here's one of the models we made of a composite materials. So we pick on a lot of stuff, not just aluminum and steel, but composites as well. And finite element analysis is used for not just stress analysis and structural engineering, but for fluid flows and heat transfer analysis. Lots of things. It's really important. It takes you beyond the classic classes and equations that you learn in engineering. The finite element analysis will solve almost any problem. And in fact, more problems than you can get with just regular, a lot of theory classes. So some degrees in aerospace in the UAH department, Bachelor of Science, a Master, and a PhD, both in aerospace and mechanical engineering are available. And we've had a lot of students in our department. In fact, we are the largest department on campus. At one time, we were 1,500 aerospace and mechanical engineering students. And lots of graduate programs, and we're a lot of degrees. We don't have a big faculty, though. The faculty is about the same as it was when I started teaching part-time there 30 years ago, but we use some part-time people like myself when I was doing that, and bring in people from industry to help teach the classes, and that's really important, too. And we have a lot of research going on in these areas. I'm not real familiar with all of those because I do finite element analysis in Moon Buggy, and that takes up most of my time. But we have a lot of external funding and a lot of research going on. UAH is a research institute facility, but we're more than that. We do a lot of training to help students get jobs, and you've heard their testimonies about how Moon Buggy has helped them get jobs, and that's my passion. Is if you don't go into research, how are you going to go into the community and help these companies solve problems in the aerospace and mechanical world? And these are just some pictures of some of the facilities we have there. There's more of that online. And of course, there's a lot of classes, and there's classes listed in our catalog and lots of details there. But in aerospace, there's several things to look at. I guess there's a slide that's coming up on that, but you can get a master's or a PhD there. And this is important too, because this is some extracurricular work. I don't understand these people. This is the Space Hardware Club. It's all volunteer. It's what it says, a club. And some of these people work almost as hard as my Moon Buggy team does, and they get no college credit for it. And that's what I don't understand. I've tried to lean on the faculty or the administration a little bit. Why don't we give them some credit for some of this extracurricular activities in a technical elective or something? But I haven't got any traction on that, but I'm trying with them. But they do several great things. They have been successful, the CANSAT and the Astra program and small payload projects and weather balloons and competitions in those areas they've won as well as Moon Buggy. And this is some pictures of the rover challenge came. That's a robot, robotic rover. They came and presented to our moon buggy class last year, and they ended up placing really high, and the CanSat won, and they do these other projects as well. So there's a lot of extracurricular stuff going on, and we are located next to Cummins Research Park in Huntsville. Those of you who've been to Huntsville have seen, we're surrounded by companies like Boeing and Blue Origin and dozens and dozens of aerospace companies. And so that really benefits UAH because it draws students from not just in North Alabama and in Middle Tennessee, but over the years I've had students from probably 40-something states in probably about 20 countries from around the world. I've had students from almost every continent except Antarctica. And, but we've, you know, so it makes it real interesting because we get a lot of people coming in to Huntsville because of the aerospace program that is there, not just at UAH, but the local jobs and NASA being there as well. Okay, so any questions? There's a lot in the works. I'm going to go out on a limb here and say that I'm hoping that the university-to-university cooperation between INTEC and UAH will develop. My department chairman and my dean were really encouraged and about this trip and making these connections with the Dominican Republic, and they told me that. And when they came and visited after the competition last year, I was asking permission of the dean to bring them over and let them see our labs and moon buggy and our machine shop. And he says, sure, bring our guest over. And when he said that word guest, you know, I said, all right, it's on. You know, this is great, and I'm glad we can do that. So I don't know how far up the chain, but we do have some other programs with other universities that I think will parallel what maybe we can do with INTEC, and I'm looking forward to it.
Oh,
yeah. If you got
For
questions for me or the team.
yeah. So the questions now are going to be to David Fikes and the whole team. Las preguntas pueden ser tanto para el señor David como para el equipo de Alabama. Usted, o sea, le voy a dar la participación a alguno que no hayan tenido primero. No hay problema. Gracias. No es discriminando. Usted va a tener su pregunta. Okay.
Hi. First of all, thank you all for being here. We're so excited. I'm actually a former member of Apollo 27 of the team here in the DR, and I'm really excited to see STEM being so important for both of us. Like, see what we are willing to do to get people together and learn about STEM and be part of this. So thank you so much. My question is, we actually have here some of the members of the new team, of the 2025 team for Apollo, and I want to know if you have any advice that you can give them based on your experience, especially you, Mr. Fikes, that have been part of this for so long. What can you tell them to be better and continue to make a great difference for the competition and all the people here that we get to inspire doing this?
What was her basic question?
What would you suggest for next year's team for them to merge better?
For the next team of Apollo.
Oh, the next team?
Yeah.
Start early. Work together, cooperation, and we typically have budget problems. And so if you can get the money issue and get your materials flowing faster, so you can get your rover built faster, because getting the rover built, you guys have to ship it. We don't. And so, you know, we can work on it all the way up to April 1st. But getting the rover, my ideal situation would be if I had a rideable rover in January, and then I had the whole month of February to test it, and test it, and test it, and test it. And when you go testing it, We build our obstacles and do things, you know, to proof test our analysis. Typically, we break things because engineer analysis it's great and it gets you so far down the road, but without the actual proof of the pudding testing, you really don't know. And I see so many rovers at the competition that break, and they break on the simplest little things. Some of them this year had trouble getting off the starting line. Well, that told me that they had not adequately proofed the rover and ridden it and shown it to your instructor and shown it to your dean that we can do this. Before you ever put it in a box and ship it, it needs to be verified. And so that's my biggest thing is getting it done as early as possible and testing it.
Okay, we have another question here.
Good morning. My name is Kelvin Marte. I'm glad to be here. I'm new in this university. And my question is for the team. Did you have any complication or frustration blocking while creating your project?
Well, yes, there was a lot of different setbacks throughout the project. One particular example I have in mind is with design of our wheel hubs. We learned about a new failure mode very late in the competition, well, in the timeline. So we had to do a very quick redesign. But facing challenges like that really are just meant to prepare us better for the workforce. It was something that we couldn't have really expected because our analysis isn't perfect, because theoretically doing it on paper doesn't account for every single factor. Until you take it outside and you start running the rover down the road, you don't know what's going to break or where. And so finding out that broke in March was pretty surprising, very frustrating, but it was a learning experience. And Will might have something to add.
If I could add to that, doing the specific part that failed was one that I was responsible for creating. And unfortunately, it failed the day that I finished machining the last part, so I just spent like weeks putting it all together. But we figured out what was wrong. We consulted again, just as a sanity check, with our Mr. Buckley, the shop manager, and got it back into production and turned it back over within a week. And that's what we like to call rapid prototype development.
We have another one here.
Hi, thank you for the opportunity. I'm a medicine student here. I feel sometimes like an outsider here because you're all talking about physics and math, and I'm about talking about how your blood pressure and something like that. But my question is, I'm always encouraging myself to do things that are different. I'm a medicine student, but I have always been interested in things that are outside my profession. And my question is, what is your advice to us? But sometimes we think that NASA is too scary, NASA is too big, NASA is too difficult. But what is your advice to us to achieve this? For me, that I'm a medicine student, how can I support your program? How can I be part of something that is bigger than me?
Yeah, so my advice to you, I know you mentioned sometimes you feel like you're an outsider in the program. If you're scared to do something, just go ahead and do it even if you're scared. I mean, you just got to get it done and do it. But specifically to stuff like the HERC program, I know we talked to the INTEC team. They incorporate other degrees, other students into their program, which is really great. You, as a medicine student, you can provide, insight on how the riders will interface with the buggy. It's training them, how their health is while they're riding, stuff like that you can really contribute to. Ergonomics on the buggy is something that, a lot of these competitions, a lot of our teams, it's kind of an oversight. We're trying to turn out a buggy very fast, and we're not thinking about how comfortable or the ergonomics of our riders. So that's one area you could contribute in. And of course, medicine and health aspects are needed for stuff like NASA because, we got to keep our astronauts healthy. Yeah.
Thank you. So Eduardo, I know. I'm sorry. We have a team member, Eduardo, that wants to ask a question for you, but I'm going to leave you, later because you can ask them later because we have interaction with the group, but these people doesn't have interaction to you later than today.
Well, hello. Thank you for visiting us. I wanted to ask, my name is Leslie. It's a pleasure. How do you manage documentation? What are the standards that you follow, and how did it evolve in the years that the moon buggy has on the rover competition?
So documentation, of course, is a very critical part in the pathway of this project. I think it accounts for nearly half of it between the presentations and everything. So the way that our process worked is we, don't have last year's team members, but we have the benefit of still having their work. And so we looked at what they presented and their scores, and we brought that together and really took a item-by-item list, very critically analyzing each part of all of those reports that they presented to NASA. And in fact, that was even an assignment that we were graded on, was each person in the team had to go through and look at that report and say, how can we do better, looking at those previous scores. And from that, we were able to improve quite drastically from last year in the scoring that we got from NASA. And so I would say that you as INTEC have the benefit of enjoying great success in this competition. It's been very impressive what you guys have done. So look at your scores from last year from NASA. Break that down item by item. Go, either across every member of your team or at least the ones who are the most eloquent writers, the best speakers, and let them go through and say, how can we really put these ideas best to paper in a way that they understand and is most cohesive. And another excellent resource that we use that I will say that you definitely should is the NASA Systems Engineering Handbook. There in that, it's very, very dense, so don't try to read the whole thing before bed or anything. But definitely take some time to go through, look at things like their methods for requirements verification, presentation of how you should have your things laid out, the topics that they are wanting to see, because you have to remember NASA as an organization has the way they like to see things. And what you have to do is your job is to figure out what do they want to see, how do they want to see that, and spin that around back on them and say, they're going to say, hey, they did this requirements verification just like we liked, or their design review was just detailed enough but not too dense. Those are the things you're looking for, and that will make a huge difference in your reporting skills.
Thank you very much.
Thank you.
Hello. Really nice to meet you. Congratulations, by the way. Well, my question, I know that everyone has asked questions about the specifications of the team and the things that you have gone through and all these things, but I want to ask something about schools. The HERG competition is relatively new in this country, especially as more and more schools are joining. And I want to know what general advice can you give to schools that are receiving proposals from their students to participate and the schools that are already participating for them to better support the teams?
Talking about the proposals?
I want to...
Getting a team started, yeah.
Yeah, so I think my advice to any team that was trying to get started and get support from their school would be to really sit down and look at the capabilities that the school can provide potentially and look at what you need as a team, because you really do have to find a middle ground there. Just with any request for anything in life, you're going to have to negotiate and be prepared to be told no. I mean, I've been told no for a lot of things. So even if they don't give you the support you initially requested, keep trying. Keep trying to get your proposal accepted to start a team. Keep trying to get their support. Even if it's something as simple as a closet to store stuff in, it can be a big help. Like a closet to store stuff in. You'll be more organized. You will have all your stuff in one place. It provides a place for teams to put their stuff. Something as simple as that can really just change the trajectory of a club or any HERG team. So just keep at it, just really try your hardest to be reasonable with them. Because I know, we as students, we really want our support from our university, but they can't always provide that. So that's something you have to do.
And do you have any advice for the schools that already have teams? I know that they have all different situations, but how can they, where should they have their mindset when they have these teams? Because it's really new, and a lot of schools don't necessarily know the implications of the whole process. Do you have any advice on that, on how could they support their teams better, or how they understand what it's really about?
Okay, are you talking about high school competition or college?
Both categories.
Both categories, okay.
How can they accommodate better their teams? How can they, because I see that school support is very, very important.
It is.
Development of the team and the rover and all these things.
If you don't have the support of the school, it's very difficult. In fact, 7 years ago, the first year I did that, Moon Buggy as a class, UAH happened to win that year in 2018, and a local high school, Buckhorn High School, won the high school division. And it looked very much like Homer, hometown cooking stuff, but because the local university and local high school wins it, but it wasn't. We won it honestly and fairly. I've had support from my university and support from sponsors, and I've continued. Buckhorn High School had it was a flash in the pan, so to speak. It was a one-year deal because it was a bunch of parents that supported their children that were seniors in high school, and when they graduated, the school didn't pick it up and support it. And so they don't even have a rover team anymore. So I would suggest to start is you've got to get some buy-in from your school, from somebody that's interested in it and will sponsor it. They may not have all the answers. They may not even be engineers or science, whatever, but if they have an interest in you, so you have to have a good advisor that's going to go to bat for you, and you've got to get sponsors, because making a moon buggy costs money, and you got to have the resources to do it. And then, if you're in the Dominican Republic, I would go see INTEC moon buggy team and say, what are your suggestions on how to start this and how to keep it going? That's the biggest advice. When I started moon buggy, another professor set me down and said she had done it before, and she said, there's 3 things you got to do. You got to do it early. You got to test it and test it and test it, and have good organization. And it takes a certain mass of people to do this. I've seen clubs do it with a dozen people or less, but it's a lot of work. The HERC handbook, which should be published any day now for next year's competition, get that and read it. And go through it and see what you're up against. First thing off the bat is going to be a proposal. NASA got so many people interested in competing, or at least saying they were interested in competing, that they had to institute this proposal writing to pick those who were serious about it. Apollo had to write a proposal to prove that they had the resources, the budget, and the support of the university to go on with this program. And we had to do the same thing. Even though we've been in it every year since it started, we still had to write a proposal every year to document that we have what we need. And NASA lays out what those requirements are in that proposal, what the answers to the questions they want answered. And you have to demonstrate all that. And so that'd be the best place to start, is go through the NASA proposal and see if you can answer all those questions, and then start figuring out, if you can't, how do I get support? And it may be even, you don't know how to weld aluminum, for instance. Well, start looking for somebody who can weld, or and try to get them involved, Okay.
Hi, my name is Tony. Okay, so since you use humans as the main source of power of the propulsion system, do you think of any situation in space where using a human is better than using an engine, for example?
So we actually got this question at a recent event we were at it was actually the NASA in the Park event we talked about. We had an engineer come over and ask us, when would this actually be used on the moon? And our answer was, well, I hope if this goes to the moon, we have a bigger team working on it with more funding and more research. Because as it stands right now, I don't think most of the buggies in the program would go very far on the moon. But for example, let's pretend that it could. One example that we would need something like human power rather than battery power on the moon is if you had a battery fail. If you have a battery fail and you don't have any other way to move your rover out on the moon, you would really want the human power. So I think that is one example of something where you would want it. But I do think that if we were to actually send one of these buggies to the moon, there would have to be a lot more work done to figure out how a human in a spacesuit would be able to propel one of these buggies forward.
Let me give you another example too. Is several years ago, Dr. Frank Six, who was the NASA father of Moonbuggy, Moonbuggy was his dream and his idea, and he wanted to get colleges involved in it. And he came to me and he says, "David, can you take one of your old rovers and make it electric?" And at the time, I didn't have any old rovers because it used to be every year they would they would compete, and then they would just disassemble them and take the parts and scavenge it and use them for the next year or something, So we had no old rovers. Well, the first thing I did was I said, all right, this is going to stop. We're not going to disassemble any rover. Once we build it, we're going to keep it. And I haven't done that true because some of our rovers haven't been very good, and so they have got scrapped. But we have, Ezekiel has seen them, we have about 6 or 7 old rovers, and we'll keep this last year's rover for sure, for a couple of reasons. One is to use for STEM outreach. If you're in the process of building a rover, how can you go to a school and show them a rover if you don't have one? And so we keep old rovers to take to STEM outreach, and our little favorite rover is a little short side-by-side. It only weighs 130 pounds, and I can load it in the back of my pickup truck by myself. And the students can do it as well. We show that. Number 2 reason for keeping the old rovers is you got these riders up here. They spent hours and hours and hours and days practicing and building up their muscles. How you going to practice on a rover that you're building? If you got last year's rover, the rover from the year before, you can take that and you can find out who your riders are going to be. Because you get on one, and if you've never ridden a bicycle very far, and you say, I want to be a rider, and you get on there and ride it around the block, your legs are going to burn. And you're going to find out real quick if you want to ride a rover or don't. And so we keep old rovers to train our would-be riders and weed them out and figure out who's really going to be a rider. Anyway, NASA challenged us to build an electric rover. Dr. Frank Six had a vision of having 2 levels of competition, a human-powered rover and an electric rover, because the real moon buggy on the moon was electric-driven. And we didn't have an old rover, so we built one. And so we have an electric rover that we have, and we showed it to NASA. But my goal is, if I have more students, I can have some working on this current year's project and some working on some side projects, is to take an old rover and make it where it's AC/DC, or it can either be human-powered or electric-powered. I think that would be a good demonstration for NASA. So I like Carissa's backup plan of having, if the batteries go out, at least the astronauts have some way of maybe getting that thing home.
Thank you so much. This is, okay, let's get an applause. This is the last question, okay?
Well, hello. First of all, I would like to thank you for being here. I really liked the first PowerPoint that you made and that you went really into detail about everything. I find it very inspiring what you guys are doing. And the second thing, I would like to congratulate all of you, because as far as I picked up on, all of you are about to graduate or graduated, and you guys have jobs or are working on internships. And as an engineering student, for me, the most intimidating thing about working in STEM or being an engineer is not really the calculus or the physics, which is insane, but the competition is what worries me the most. And I'm just getting started. I'm barely going into what would be my sophomore year. And I would like to know from students that are about to graduate or that have already graduated, what would you say are some skill sets that you guys think are important for people like me to develop while I still have time? Or some things that I could work on that, from what you've seen, would help me when I go professionally to work or to set me apart from the competition?
Yeah, so you said you're a sophomore, right? Okay, so if you're in your sophomore year, that's the perfect time to start looking for some experiences you can get before graduating. If there are any internships or co-ops, a co-op is where you work an internship during school time. It's a little bit more of a heavy schedule, but some people make it work. So if you can get any professional experience, do that. If there's any opportunity at all, do it. Even if it's unpaid, doing 8 hours of shadowing a week, unpaid, that's experience on your resume that will help you later in life. A lot of people have trouble if they don't have anything on their resume with getting a job, getting interviewers to take them seriously, but you can still do it if you do not ever get professional experience in school. The ways you can do that are by working on personal projects. A lot of people at UAH work on personal projects for interests that they have. Maybe they want to demonstrate some sort of, like, for example, a drone that they found interesting. They'll design that drone, make it, and demonstrate that they are capable of working on a project like that. So even if there is no hard program set in place for you to get that experience, you can make it yourself. And programs like HERC, we all talked about how it's helped us in job interviews. Participating in student-led programs like this really sets you apart from other people. It shows that you have initiative and drive and that you're really striving to be successful in it. Do y'all have anything to add?
I would just add she's absolutely correct, and it's also really about how you market that. You can do anything, and the way that you can use that to your advantage is as long as you can identify the critical skills and the things that these people are looking for, and make sure that before you go to an interview or write your resume, learn how you can tie all that back together and show them, just like with the systems engineering handbook. Know what they're looking for and relate what you have as your skills back into that. And that's your job as a prospective employee, is to market that to them so they can understand who you are.
I think also another important thing that is sort of overlooked, but like we talked about earlier, is the soft skills. I know for me personally, when I was originally trying to get internships, it was a really important thing that they pointed out to me was just being able to communicate well, showing that you'll work on a team well, because that is something that a lot of engineers can kind of struggle with and people in STEM can struggle with. And so just developing those skills and being conscious of how you're interacting with like teammates is a really important thing that employers will notice.
Bien, y de esta forma finalizamos la última ronda de preguntas. Otro fuerte aplauso para el equipo de la NASA HERC de la Universidad de Alabama y el profesor David Fikes, quien, bueno, apurado por el tiempo, omitió en la presentación su biografía, pero queremos que sepan que es un profesor que posee una trayectoria de más de 46 años en proyectos aeroespaciales y mecánicos, incluidos interceptores de refuerzo de defensa contra misiles balísticos, pruebas de calificación de elementos de la Estación Espacial Internacional, integración de sistemas de transbordadores espaciales, ingeniería de pruebas de propulsión y túnel de viento y desarrollo de sistemas aeroespaciales avanzados. Así que haberlo tenido aquí y que haya compartido con nosotros ha sido pues de gran provecho y le valoramos muchísimo. Un aplauso para él. Asimismo, queremos agradecer a todos ustedes, a los chicos de la Universidad de Alabama, al profesor David Fikes, a todo el equipo de la NASA, al Mr. Kevin, si sigue conectado con nosotros, y a su esposa también que le acompaña, la señora Clara, que ha estado ahí pues tirándole fotos y bien también disfrutando de todas esas conferencias. Agradecerles a los representantes de todos los equipos de NASA HERC aquí en la República Dominicana, a las autoridades que nos han acompañado, al público en general, a quienes se han conectado a través del canal de YouTube del INTEC. Gracias por haber participado esta mañana con nosotros. Les hemos preparado, bueno, mañana tarde también porque ya pasan del mediodía, les hemos preparado un brindis para que al finalizar pues puedan seguir compartiendo. Queremos mencionar que al finalizar y pues los que quieran inmediatamente pues continuar el brindis, mencionar a los capitanes que se encuentran aquí presentes y tutores de los equipos de la NASA HERC de República Dominicana, permanecer en el salón para realizar una grabación brevemente. Igualmente, pues los chicos de la Universidad de Alabama y el profesor David Fikes se quedarán un momento más entre nosotros, que ahí también podrán aprovechar si quieren conversar, hacerle alguna pregunta. No les tomen mucho tiempo porque ellos tienen una agenda también que agotar aquí en la República Dominicana y tienen otras actividades, pero si brevemente le quieren pues hacer alguna otra pregunta, estarán entre nosotros. Y fotos también si quieren tirarse. Ellos están ahí, están felices de compartir con nosotros y en toda la disposición habían solicitado pues eso, tener este acercamiento con todos los jóvenes dominicanos. Nuevamente, gracias y feliz resto del día. Importantísimo, al equipo de Sabine, de la profesora Sabine y todos los traductores que también hicieron esto posible. Gracias a todos ustedes.